There we go. We are live. Live. There we go. One. All right. So what we're gonna do today, because yesterday we got this working. Look at that. Let's get the wheels. Let's get reverse and the wheels working. Okay, so do dismiss, 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 dismiss. Do. Let's go to settings. I've done uninstall that plugin. I don't want to be harassed by it. There's the not the Copilot, but there's the actually wait, I should probably restart, yeah. Just restart the IDE. Now I won't have the Copilot stuff on the side. There's this one, JetBrains AI, but I think I have to pay for that. I'm not sure if that comes with my package. JetBrains AI. Supercharge your tools, embrace the new freedom. I'd be willing to try it at some point, but for now I think I'm gonna yeah. Senior director. Oh, that's OpenAI. Yeah, I think I'm just gonna keep it disabled for now. That Copilot. Can I uninstall? Okay. So this here, we do the drive force here. This is the gas. So what we want is drive force. What we want to do is if we have brake force, we want to apply braking. Want to apply braking. Give me a second here. So wheel. This is wheel dot steering angle. That's not what we care about. Suspension. This one hit data. Wheel hit data. I think this is it. No. Wheel. This is the wheel here, which is coming to this wheel here, which has the grip factor. This needs more information. But one sec, where were we? I don't think that's actually the system that we care about, because what we're looking for is where we're using the player input, right? Like where's this here being called? Find usage. Yeah, and then here. Yeah, it's this one? No. Maybe? No, this is creating it. New player move input. Find usage. It's not what I meant. Okay, so something's using the player input. Player move input. In the systems. There it is, right there. I believe it's here. Yeah, there we go. And then this is the drive control, which is a wheel drive control here. And what we want is public float uh, brake amount. How did that auto complete like that? Oh no, I guess because like it's zeroed out, right? And then... no, but how? Why would that auto complete like that? Okay, whatever. Um, then it'd be public float e-brake brake amount. But I think e-brake amount is actually a misnomer because it's a button. It's not actually a trigger. So I think it should just be a byte, but whatever. I'm confused. Is this enabled? No, this is okay, it's okay, whatever. Whatever. Yeah. Mm. All right, wheel drive controller, find usage. Vehicle input. Right here. This would be drive controls dot brake amount equals drive controls dot e-brake amount. Why is it better now that I'm not using Copilot? Like I actually have Copilot uninstalled and now autocomplete is better. But autocomplete's a little too good. Oh, wait. Get the gas multiplied by the e-brake amount. Okay. Yeah. I don't know how it's like I could swear that this needs to be like AI to fucking do that thing, but like Fucktify now. Visuals. So I don't think the visuals are actually getting hit at all, right? Like if I go do a debug.log here. I don't think this is ever getting hit. This isn't getting hit, is it? The drive system? No, that's the debug. Control here. Yeah. And drive force. Yeah, okay, so drive force here. So this is where we're actually calculating the amount of torque required for the drive force. If wheel drive controls dot brake amount is greater or equal greater than 0. Wheel drive force. Oops. We effectively want to take we want to take this and then our torque we want to add so our drive force wait, the wheel drive force. Yeah, the wheel drive force is what we're coming in with. Just applying the torque. Where's ooh, it's drive amount. Yeah. Here. This is effectively what we want. I think yeah, it's a float. Temp drive amount equals 0. Uh, actually, wheel drive controls dot drive amount. Something feeling so weird about that. Temp drive amount. Plus equals minus brake amount. Remove the amount. Oh, wait. This needs to be times 2. Ideally, we want a curve on this one. So this should be a curve in the future for brake torque. Then instead of a drive amount here, we do the temp drive amount. So I should have forward and reverse now. Just doesn't work. I don't even think that it's updating it. Yeah, okay. Control brake amount, which is set through here, right? Yeah. Debug.log drive brake. No, sorry, brake amount. Brake amount. This is what we care about right here. It's always set to 0. Wait, is it because I don't have a brake? No, it's totally there. And I could have swore that I was actually getting it. Yeah, no, it's totally there. It's just, it's not hitting in here for some reason. So something's getting lost in the input system. Oh, wait. There's a car input. This. This is our execute. Let's do a debug.log. Okay, this one here, we're actually going to do the all the stuff here. So this would be gas. I still don't know how I feel about that. Steer amount. Our inputs dot steering. Steering. Brake amount. Car e-brake. I don't care if it's not burst compatible right now. Okay, so that is being set. So if that's being set, we should be able to see it in here. No, not here. Sorry. Vehicle system. We should be able to see it in the vehicle control system right here. But this is the wheel drive controls. Drive amount. Wheel. My wrist feels funny. Steer amount. There's our brake amount. No, our brake amount is working. Oh, wait. It's because we have ABS. When we apply the force, we have an ABS somewhere, right? Right here. Yeah, this here is the problem. So what we're going to do is we're going to do that. Actually, no, because, yeah, we're saying, hey, remove any brake amount to the total drive amount, and then that gets added to the torque. right? So if we do a debug.log, we say torque. It's not applying. Wait, this still has a break amount? Where's my debug? My debug here. I think it's in here, right? Oh, wait, here. This is the one that's getting logged. It's not actually what we want because it's eating up our eating up all of our stuff. This is what we want here. We have no torque. Oh, I know why. I know why. Break amount is equal to 0. These are ands. That's cool. I didn't know about that. I like that. I wonder if that takes anything away. Patterns are nice though. There it is. We have we have reverse. Whee! Now, I don't think our wheels are actually being animated at all, right? So with that, we want to actually we want to fix it so we're actually on the ground. Then once we're on the ground, then we can fix. We can take a look into fixing the rest of this because we've got steering now and we've got forward and reverse and brakes. So that's the most important parts. But I believe that the issue now is with these. Ooh, sorry. So I believe these need to come up like this. Those wheels need to change. I need to fix this wheel. But for now, it's dualies in the front and dualies in the back. So good. Okay. Oof, that's not quite what we were looking for. That's weird, right? Like, look how in the ground we are. That steering is intense. Look at that steer. Okay, so we're firmly in the ground. And the reason being is that our suspension is way off. Although I think our suspension's still a bit off there. We don't want that much travel. So we'll do this. There we go. But we have the wheels have no travel at all, right? Now, I still think that there is actually pressure being applied. So like if I come back into this scene and I add in like some obstacles, right? 3D object cylinder. Yeah, here we go. We're going to add in some cylinders. Don't care about capsule colliders because we don't actually use them. We want a physics object. Physics body. There we go. I think this should be the what we're looking for here. Did I do this wrong? I might have done this wrong. I don't know that it's hitting. But what if it's not hitting because it's not flagged as drivable? Yeah, that might be it. Okay, let's see. No, that's just nothing at all. There. But oh wait. The cylinder's not in here. That's probably why. Environment. It's like why am I just like driving straight through this? Okay, so this should offer something? No. What? There's physics body. Oh, it's physics shape. That's what I needed. Wait, what the fuck? There we go. Okay. There we go. Yeah. So it does work. It's just the wheels aren't working. Well, we can tell the wheels aren't working because we don't have any like the wheels don't spin. So the graphics are just not working at all. Wait a second. I think I think I think I have the back wheels as drive as steering and the front wheels as not steering. Wait, do I? No, that's the steerable one. Okay. Yeah. All right. Okay. So we have steering, we have forward reverse. Now we want to go to the vehicle wheel visual system. This is the one here. So this I don't think actually is ever executed. Debug.log. Am I running? Sorry, give me a second here. I have a little bit of tendonitis coming on in my left arm. So it's bugging me. Okay, so if I go to console and clear and then hit play. Yeah, it's like straight up just not actually ever running at all. Like we don't see it at all. So, oh wait, no, that wasn't the scene, was it? Yeah, here. This is what we want. Dots here, the wheel mesh. Uh, rendering material mesh information. So we have a bunch of like rendering stuff, but it's not actually executing anything. So if we come back into here, what's it require? It requires a wheel, which is iComponent wheel, which it doesn't have. And that's why it doesn't have the wheel. Find usage. Loading managed type is not supported. Unmanaged. What? Interesting. Get wheel base distance. And then we do the wheel here. There's the var wheel. But where is this getting attached? This is a wheel entity, local variable wheel entity. And this is the spring 0. Vehicle baking data. This is an iComponent. Where's this being used? Find usage. This is in the vehicle baker. Right? The vehicle baker? Here's our vehicle bake. No, this is missing the baking step altogether, I think. wheel drive controller. I don't think these wheel entities are being attached correctly. See, on update. Yeah, these components are not being added correctly. Let's take another look here, and we'll come into here. And we want to grab one of the wheels. It doesn't matter which one right now. These are all Unity. The wheel data is not actually being attached anywhere. Okay. Okay. Good, good. But I also think this is an actual problem with this game as well. Like, I don't think this game actually has a wheel baking system either. Like, the wheel baking system, I think, is broken in this too. I think the logic is sound. I just like the process of doing the update is sound. I just think that the bake isn't happening, so we're never attaching the relevant information to the actual wheel itself. Yeah, I think that we still don't like in here we don't have the wheel bake info as well. So let's take a look. It's hard to tell though because like there's not a lot of places where we see the wheels. Oh no, the wheels are working. Never mind. So it's just in my code that it's not working. Yeah, the wheels are spinning too. Let's see if we can get this back wheel to go up. There we go. Yeah, no, it totally does work. Okay, so it's definitely my code that is at fault. So it's gameplay, vehicle wheel, new window. Let's see what we've ripped out that was wrong. And this has a wheel. This wheel here, find usage. It's in the wheel, it's in the authoring. Wheelbase. Get wheelbase distance? Oh, yeah, yeah. So what's the big issue here? I don't think that we get access to the actual vehicle itself anywhere in here. Let's do common. There is kind of the problem of like these prefabs don't really work super well for what we want because like I think they're definitely missing some stuff. Linked group authoring. Box collider. Can I just do a box collider? I would like that. Just give me a second here. Not a sphere, sorry. Oops. Here. Yeah. Then we just want a cylinder. That's another cylinder. And another one. There we go. And we just want to do this on its side here. This being 90. This doesn't look much like a cylinder, does it? There's something capsule-y about this. All right, let's see. Let's see if this works. It did. Okay, sweet. Good times. Good times. Okay. Oh, that's cool that we get a lob like this. And then I think it should be called at like this distance, to be honest. And it's like it's called here. It's called here. And it's definitely too small to see. I guess we don't have popping issues, so whatever. But still, it's interesting. Okay, hit play. We should see this race car somewhere. Like, where is this vehicle? I was really hoping to see the vehicle somewhere. Where are you, vehicle? Whatever. This is me. This is them. Okay, yeah, here. So we have the wheel, right? And the wheel is getting used places. And this is what we need to find usage. I want to say that it should be in here, right? Vehicle authoring. This should work then because this is doing this the same way. Visual mesh is it a visual mesh issue? Where's visual mesh coming from? Wheel visuals. Wheel mesh right there. Yeah. Okay. Mm. Okay, so we still have the wheel mesh and stuff like that, but we're not seeing the wheels. why why we no see wheels? It's not being attached to the wheel itself, which is a problem. Um, that is here, and then here we have the wheel itself. No, the wheel entity. The wheel entity is grabbed through here, right? So if we do debug.log wheel ID, taking data dot. Oh, sorry, no, I just want wheel entity. Wait. How is this working? Here's wheel spring. One sec. I think I know the issue. Find usage. No, that's not what I was expecting. Yeah, this is this is definitely interesting. I feel like this is for instead of dynamic, it's for renderable, right? What if I do renderable? I wonder if that will change anything. I feel like it won't, but yeah, no, still nothing. Wheel mesh objects. These can be. I'm just gonna put these back to dynamic because dynamic is less work on the system. Huh. I feel like this here is the problem. Oh yeah, that doesn't need to be there. Wheel entity. Okay, so we have the wheel entity. Yeah, it's not being placed on that or on this at all. Big fan, bruh. Oh, thank you. And welcome. Or welcome back. So I gotta figure out why this isn't being attached to the entity correctly. This is our wheel entity, right? And this is the spring. Switched to. Where are you from? I'm from Canada. The good old Canadas. What about yourself? Entity manager, add component data, entity steering. That's fine. This is the one here? No. Here's our wheel entity, drive controls. Wheel entity wheel. Yeah, this one here is the one that's not working correctly. So where's the wheel again? Here's our wheel. Here's where we make our wheel. Ooh. Yeah. Okay. So we make our wheel. We then come down here and we attach it. And this is the wheel entity, which is defined. Where's wheel entity being defined? There's wheel entity equals wheel entity. There's wheel entity. Wheel entity here. Wheel entity is being defined here. So as far as I understand, the rest of this is probably getting applied, right? Because the suspension's all working, right? So the suspension works. And if the suspension works, then the rest of this should work because this is attaching the suspension data. This is attaching suspension data. Wait. Is this attaching suspension data more than once? I still don't know why this is an on update. Like this shouldn't be changing. This information shouldn't be changing. What is your game name, bruh? Isekai Crusader Truck-kun's Realm Rescue. I'm switching it over from Unreal to Unity at the moment. For Unity dots. But this is the last build I did on Unreal. And then I ran into some bugs and I had to make some changes. I think Shibuya in this build is like completely washed out and it's just a white screen effectively. I went through and I updated so the impacts are better. And then I was trying to update some of the AI for while the girls are walking around. And it was just and it ended up breaking them, which annoyed me. But let's do main menu. So that's the big map that I have. This one here was one of my test maps. The general idea is there. I could launch up the Unreal project, show you how these girls just fly. The way the girls are in the project itself are probably what I'm gonna aim for Unreal. I mean for the Unity build. Let's see here. And while we wait for this to load, I'll post a link. So you can actually download the most recent build. I try to update the builds quite often, but obviously I'm playing the waiting game effectively for the next build because I'm doing the switch over to Unity, and to get a build in Unity, I at least need a working product, right? And the vehicles in Unity are slowly killing me. Here we go. This is more along the lines of what we're aiming for the hits. Something like this. A little bit more airtime, right? But as you'll probably see, these girls are starting to spawn pretty high up into the air, and their capsules are not in the right spot. And that's an issue with the AI system for it's an issue with the AI system for the mass entity system in Unreal, and because of that it causes problems. Yes, this is my game. The current models are placeholders, except for the truck. The truck's not really a placeholder, but it's not finished. Why are you killing people? Oh, so the point of the game is you are tasked as a truck. So you're is this game concept? So you are tasked as a truck to drive around the Shibuya area of Tokyo, which this is a rough layout of Shibuya, a small section of Shibuya. So you're tasked with driving around the Shibuya area of Tokyo and hunting down specific people, which in this build I've just called targets, which are these girls in the skirts right now. And you isekai them. You help them over to another world to become heroes. To save the world to save other worlds from demon lords. I don't know if you watch much anime, but it's kind of a trope in the anime sphere that you get hit by a truck and you go to another world to save it. As like an overpowered superhuman person kind of thing. And I figured, fun idea, you know, we've got the mass entity system. Let's see if we can build this into a game. So yeah, you're the entire point of the game is just to run. But the end goal is you hit the targets and run them over, right? And the targets give you points. What the point system is yet to be decided because we haven't gotten far enough to like figure out what's fun. And then these ones that are like walking around or in the white shirts and the blue shorts, these are pedestrians. You shouldn't run these. You shouldn't run them over. You should avoid running these ones over because they reduce your score, whatever your score is, right? But these ones, those ones you're supposed to run. And this is my entire game. Whee! Yeah, so lots of ragdolls and lots of moving parts. Yeah. But if you'd like to play a build of it, it's available at the itch site. And right now, I am trying to get the wheels to work in this Unity build because they're not working properly. There is definitely a problem with like the steering. But we'll come back to that. It feels like right now it feels like you're on ice when you're driving around. So we can, now that we've got the vehicle kind of working, what we could do also is we could actually, no, we can't because we don't have the camera. Once we have the camera working as well, we can actually start driving around the city. But the goal today is to get the wheels working, and once the wheels are actually visually spinning and going up and down, then we can move on to the camera. Once the camera's working, we can move on to ragdolls. Ragdolls are going to be important. Once the ragdolls are done, we move on to AI. The AI is going to be fun. The AI has to be built entirely. So the thing about Unity, which I didn't realize about the Unity dot system, is that the Unity dot system effectively comes with like some very rudimentary things and a physics engine. And then outside of that, everything is on you to build. Right? So there's no AI systems, there's no driving systems, right? Or anything like that. It's just entirely just, you know, go do the thing and that's it. And it's just like, oh, that kind of blows. I'm also going to have to add in AI for vehicles because vehicles are going to have to drive around the city. Although I think the AI for vehicles is going to be pretty simple for the most part. We're going for a happy, fun kind of system. So this is partially working. I don't know why the wheel rendering data is not working though. Like this should be working. But this is never being applied where the other stuff is. I believe this, let's see. Here's our wheel entity. We do apply the, I also want to learn to make games like you. Oh yeah, making games is kind of fun. I am by no means an expert. This will be my first game, so my first real game. Now made with two different engines. Why? Because I hate myself. Where is the suspension being placed? Because that could actually be a problem too. We don't have any suspension. Can you suggest me? What would you like to know? You are welcome to answer questions, and I will do my absolute best to try and answer them. Oh, I am getting a wheel. Here's the wheel right here. Yeah, there's my wheel. There's my suspension, and there's my wheel. Yeah, okay. So if that's the case, I should have something, right? Like it should be working. But yeah, no, the wheel, is it supposed to be on the wheel mesh that gets it? Where's the rendering? Visual system, wheel visuals. This never runs because nothing has local transform wheel hit data. Oh, do we not have wheel hit data? Is that what the problem is? Okay, so a wheel here has the common wheel. Yeah. Does this have the wheel? No, I don't see it here. So it's on the suspension. This one here. There's the common wheel. Do we have the wheel hit data? Wheel hit common. Yeah, wheel hit data. There it is. There's that and the suspension. We come back to the code. We have wheel suspension. Use racing common. Keep it up, bro. You were doing good. I'm getting there. But yeah, well, you're welcome to ask as many questions as you want, and I will do my best to answer them. So feel free to ask. Yeah. Let's see. This is suspension. Wheel hit data and this. So these four are actually attached. Actually, maybe we don't have a local transform. I feel like we should. Like local transform should be on everything, right? Local to world. Local transform there. Okay, so we have local transform. We have the wheel. We have the suspension. We have the wheel hit data. And do we need anything else? No, just those four. So we should be running this. So the only thing that I can think of is this here is invalid. And we forgot to stop this. Yeah, so Gaming Beast, if you're looking to get into game dev, the best way to do it is just to kind of start. Just find a project that you like and go. What does can you tell me about your channel? Wait, wheel ID. Steering input. This is still not triggering, I don't think. Debug.log. We don't need this torque anymore. We've kind of done that already. Where is the steering? Here's the steering. We don't need this anymore. We can just comment this entire thing out. What we'll do is we'll do this though. Was there anything else that we wanted to remove a debug for? There's our wheel entity. This doesn't seem super important anymore because we've verified that that's actually working. And then it is here that I don't think we're getting what we want. Because I don't think that I'm seeing the I'm running.
Drilling the default one is supposed.
Okay. We can clear this. We don't need that data anymore. And then we're gonna go forward and see what happens. We see nothing. Yeah, it's not running that job at all. Okay, so that's the problem. Wait, where's my IDE here? This is never running. And this would only never run if this wasn't being used correctly. State. Schedule parallel. Maybe this isn't actually running on update. Debug.log. Would this be? This would be update wheel visuals system on update. Oh, that's not running. the visual. This is not running at all. So this isn't running. This we never execute this line of code. Why would we not? World system filters. Transform system group. Do-do-do. Oh, I totally get what you meant now when you said, "Can you suggest me?" I don't know anything about your channel, dude. I would have to go look into it. I thought you had questions about game dev. I'm totally down to answer all your questions about game dev if you want to ask. Let's see. It's got to be this like update before or the world system filters. I'm assuming this it's probably this thin client simulation and I feel like that's probably yeah, I feel like that's probably a networking thing. I'm borrowing code from a GitHub project from Unity. Let's see. That was totally it. My wheels still don't spin though. They don't spin, but they go up and down. Beautiful. Oh god. Type of simulate. Wait, was I'm running? Yeah, okay. So we can clear now. What is your good name, bro? I'm a little confused. YR name? Let's see if we're getting past that for loop. Or sorry, the if statement. I don't actually know if we're getting past there because you can't attach a debugger, unfortunately, to this. I miss my debugger so much. Having a proper debugger is super important. I'm running. Okay, so we're still making it past there. So it's just something in the... I wonder if it's only because it's dynamic and not actually flagging it for transforms, like for rendering. What the fuck just happened to my chat? That was weird. What in the blue hell just happened there? My chat just disappeared. That's confusing. Anyways, it's probably this rotation stuff isn't being assigned correctly. Axis, math up, steering angle, axis angle. There's a rotation. There's a wheel visual, and the rotation isn't working. The position's updating, but the rotation's not. I wonder, there's got to be an issue with this. And I almost wonder if it's like, if it comes down to like, which one's the one that has, which wheel is it that I'm using that has the -1? This is right. Okay, so that's the side. Can you give me suggestions about my channel? Dude, I am probably not the right person to ask about that. Just because like I do not run a successful channel. My channel is unsuccessful. But like if you want to really know about like getting out there and like building a successful channel, there's a couple really good ones. My favorite is probably Devin Nash. And I probably spelled his name wrong. I did. This guy here. You might not always like the things that he's got to say, but he's very honest. And he has like, so he's a marketer, right? Like he does marketing professionally. He's a CEO of a marketing company. And they have massive ad spend. And he runs numbers and has ran numbers for some of the largest Twitch and YouTube people, streamers on the market. So his focus is definitely on streaming, right? But consistency is usually the king, right? So like as far as like getting out there, you want like consistency, and you want to push the boundaries of like content, right? Like you want to make something that you want to watch, right? Make if you're making content that people want to watch and that you want to watch, that interests you, then you're doing well, right? Eventually you will get picked up. But the number one thing that you need to focus on to grow as a content creator is working on and mastering making content that people care about, right? And it's such a very broad way of putting it, but it's very true, right? Like, so if you are making tutorials, right? Because that's like the only thing that I've done, really, as far as like putting out like YouTube stuff. It's like I've made some tutorials. If you focus on tutorials being taught in a way that you, so like if for me, I was doing because I was doing Unreal, right? So like if I go over my channel, I have a couple actual videos, right? So like my tutorials here are like, these are the tutorials that I wanted, a tutorial style that I wanted when I was trying to learn how to use these things, right? It's not like 20 minutes of filler, right? It's just, this is how it's done, right? Because for me, that's all I cared about. Somebody left a comment on one of these where it's just like, this is barely a tutorial. And it's just like, if you think that it's barely a tutorial, it means that you're not the correct audience for this tutorial, because this tutorial is meant for somebody with a higher skill level than you, right? And that's not a diss at them, right? Like if you're just starting out with C++ and Unreal, this is not a good tutorial for you. If you don't know C++ already, this is probably not a good tutorial for you. You need to know a little bit of Unreal and C++ in order for this tutorial to be worthwhile to you, right? This is a tutorial for a software developer coming into Unreal, has very little knowledge of Unreal, but understands the core elements of C++. So if this if you do not meet that category, then this is not a good tutorial. This is a terrible fucking tutorial. Doesn't explain like anything. It just like these are the core concepts and like this is how you stitch them together in C++. Go. Right? But that's like all I wanted, right? Like I didn't want like how to build your somebody's like complex like movement system that's like relevant to like that has too much relevance to a specific thing. It's just like no, this is like how you integrate this like the enhanced input system into C++. And if you're confused about that, or like if you're confused about the enhanced input blueprint side of it, there are many tutorials to like go go like go learn how to do that there. Right? Bro, you were so honest. Yeah. Well, yeah, but like so the person who left the comment that was like this is barely a tutorial, if they keep going with Unreal and C++, they will get to a point where this is a tutorial that works for them. Right? They will see the value in this tutorial eventually. If they keep at it, right? If they don't keep at it, they'll never see they'll never see the value in this tutorial, right? And this is not a perfect tutorial, right? I did so many things wrong in this. Like I could probably have trimmed it down to like under 6 minutes if I went back and did it now. Not that I'm like amazing at it now. I'm still dog shit at this, but like I can trim stuff down, right? But yeah, like it's like how to do double jump, right? Like this is how you should probably actually do double jump in Unreal, right? And you go to the other tutorials and it's like, all right, so we're gonna start, we're gonna open up this controller and we're gonna spend 15 minutes going through, you know, doing this, that, and the other thing. And it's just like the answer is that there's, you know, yeah, you just want this to the jump to trigger on started instead of triggered. And then you come into the third person character here, and if you scroll down to the very bottom, not max jumps, you want jump, and then it's here max jump count from 1 to 2, and now you have double jump. You want triple jump, you change that to 3. Right? And then the complaint is that like it doesn't take care of like the rest of it, where it's like, you know, it doesn't play an animation or something like that. And it's just like, yeah, but I I I wasn't trying to play an animation. I was trying to implement double jump. The tutorial's not supposed to like teach you everything. It's supposed to teach you the concept of this is how you implement double jump in Unreal. And the answer is not to start dragging blueprints around. The answer is to use the pre-built double jump because it's already taken care of for you. But yeah, just focus on the content, and you just got to keep working at it. You're gonna fuck up a lot of videos, and you're gonna make a lot of trash. And every now and then in that trash, one of those videos is gonna be great. And eventually, most of your videos will be great. Well, you look at somebody like Mr. Beast, right? And Mr. Beast didn't get to where he was right away. He had a long history of being a trash, what would be considered a trash tier YouTuber, and putting out garbage slop, right? And it's just the most charitable way of putting it, right? To like, because like what it is it's not like no effort videos, right? It's just that like it's he put effort into his videos, and he put effort into into YouTube. It's just he wasn't making something that connected with people. Yeah. Yeah. So like Mr. Beast didn't start out making content that connected with people, but he grew into it, and he figured it out. He figured out something that he could do, that only he could do, that connected with people, and he could make videos about it. And luckily, he had enough editing experience and whatnot in the past, because of all the shit that he put out beforehand, that he was able to produce a video that was good, right? Another one is like if you look at that one that what's that guy's name again? He's one of the he was a big YouTuber, sorry, a big Twitch streamer, and then he moved over to YouTube and he's been making a lot of like YouTube content. Ludwig. So like if we take a look at Ludwig, right? Ludwig did that thing where he started another YouTube channel in secret, right? And did a couple things to like promote it and get it shouted out on some big streamers and stuff like that to like build up an audience for it and stuff like that. Sure, but like at the end of the day, the only reason that that did well is because he had good editing. It was structured well, and um, the video was entertaining and informative, and most people found it informative, right? But if you put together something, right? If you're not used to telling the story, right? Because all videos are just telling a story. If you're not used to telling that story, and you were to do the exact same thing that Ludwig did, the entire channel would fall flat on its face and it would never amount to anything, right? But if you can do video storytelling like Ludwig can, or like Mr. Beast can, or like all of the big YouTubers are really good at video storytelling, right? If you can do video storytelling like them, it doesn't matter if your channel is just starting out. It doesn't matter if your channel is massive. You will still build an audience, right? So the focus should be on honing your skills and getting out there, right? Just hone your skills, keep producing stuff, and eventually, if you keep doing it long enough, something will click and you'll do it. It's just like, yeah, it's how I started programming. I just kept smashing my face against the keyboard until it worked. And now I can educate myself as I smash my face against the keyboard, and then things work faster because I can smash my face against the keyboard with an educated mind instead of an uneducated mind. So why is my rotation not working? Yeah, because like I've been using Unity for all of like 2 weeks, 3 weeks. This is my third week, I think, of using Unity, and my third week of C# programming. So I think in my first 2 days though, I got like a vehicle driving around. You know about the dark web? Yes. It's relatively it's kind of a boring place. All the dark web is a website that is not Googleable effectively. So like it's a website that doesn't have a proper domain. So like if you've got a website and an IP address, that's a dark web website. Doesn't mean that it's doing anything illicit. Doesn't even mean that it's underground. It's just like underground. It just means that it's yeah. I also know about Onion, like the Onion system. I've never played with it or dabbled in it. There's just nothing there that interests me is all. So what is your opinion on this? Uh, wait. So drive force. Here's our angle. This is the rotation angle. Here's our steering angle. Here's our rotation angle. Does this need to be this, or should it be not this? I'm going to try that. I have a feeling that this is the problem. Actually, you know what I should do? Actually, before I do that though, I'm just gonna come along and just do this. Wee, 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 wee. Okay, and then we're gonna come along here. What I want to do is I'm gonna move this over like this. And we're gonna do 180. There we go. Then we're gonna come in from the other side so we can see the other side of the wheels. See if the other wheels are moving. Wait, are they? Oh, they are. Okay, bro, Brian, nice to meet you on this platform. Nice to meet you as well. Take a look at your YouTube channel later when I got some free time. Okay, so the wheels do work, but only when driving. Like only when pressure is actually being applied. Okay. I still feel like we're on ice, so that's kind of interesting. Okay, so wait, does this hold true on this side now too? Oh, the wheels are full on working and we can see them turning and everything. Okay. Fucking dope. Fucking dope. We got it working. It still feels like ass, but like we got it working. I think we need the steering, the turn radius to be a little bit less. Right now it's 11. 11.3. Let's say 5. Let's find out what 5 is. 5 feels noticeably better. Yeah, 5 is definitely noticeably better. I have no idea where the Oh my god. I love the way the thing just like fucking whips around like that. That's fucking great. Alright, let's get a bigger screen here. Wait for it, wait. Whee! Whee! Wait, where'd we go? Whee! Wait, I don't know where we are anymore. It is so easy to spin out like crazy amounts. Wait, my grip factor on my front wheels is 0. What? 0.9. No wonder it feels weird. Oh, that already feels better. At least we found the problem. There we go. We have a driving a vehicle that actually drives. This is crazy. The wheels go up and down a bit too much though. And then when we're not actually driving, they don't move, which is not good. So we need to apply some level of driving to them. So when you're rolling, things actually work. Let's see if it still works with this 360%. Yeah, it still does. Okay. I'm doing pretty good. What about you, real Any? My back wheels still spin. Yeah. Okay, so we can spin. All right, so we need the wheels to move when we're just doing that. Doing great. That's good to hear. Okay, so our rotation doesn't update when there's no when we're not applying force to the wheels. Hmm. Because it requires drive force, which it should be linear velocity. Huh. This needs to be this needs to be based on the uh of the vehicle, not the drive force. Recently came across your channel and it kind of looks like a hidden gold mine. Oh god. Probably isn't. But thank you. Still trying to figure out what type of content to make. The local transform allegedly is wrong. Which is kind of interesting. Seems to be right so far. So I need something that will give me something to work off of that is not drive force. So we'll come back to that. But in the meantime, I think that we've got the vehicle in a situation where we can start working on like a camera. Hmm. Okay. Do, do, do. Okay, let's see here. We want now we want to get a camera following the player around now that we've got everything working. So now we need a follow camera, which will be over here. YouTube.com. Unity dots follow camera. I think we're probably in a pretty good spot to like.
Video, I'm going to be showing you how we can. Hello everybody and welcome to today's video where I'm going to be showing you how we can follow entities using a Unity camera or the Cinemachine in Unity. Now when I say entities, I'm of course referring to this in the sense of the entity component system, which is part of Unity's new data-oriented technology stack, which doesn't yet have its own implementation of the Unity camera, so we have to do a little bit of workarounds. So that's what I'm going to be showing you how to do today. Again, I'm going to be showing you how to do this with a traditional Unity camera, and I'm going to be showing you how to use the Cinemachine camera. And if you don't know what the heck I'm talking about with the entity component system, data-oriented technology stack and all that, I definitely suggest checking out this playlist right here where I go over kind of what these concepts are on a high level, and then I give you some tutorials about how to get started with them. Now really what we're going to be doing in today's video is essentially syncing the transforms of an entity with a game object, and so this applies to
in UE, would you suggest that I keep trying to understand how to import a character class properly, or I should continue my learning journey even if I might forget things along the way? Well, you should always just continue, but you seem to use tutorials a lot while working, so I thought you might have a better idea on this. I use a fair bit of tutorials sometimes. But like I'm using tutorials for concepts mostly, right? And then I'll change so much for it. Oh, implement, not implement. Yeah, okay. It Sorry, yeah, I misread that. Understand how to implement a character class properly, or it depends on the style of game that you're making, right? So like if you're making a game that requires a very customized character control system, then you can't really get around implementing a lot of those systems yourself. But as far as like as long as you can get it working, the more times you're never going to remember something the first time that you do it. It's going to take multiple times, right? So having like either writing it down, making a tutorial for your own purposes kind of thing. However you want to document that so you can come back to it when you go to make something else. Yeah. I'm trying to learn C++ game programming concepts in UE. Yeah. So yeah, like there's not a ton to control systems in Unreal. Well, it depends. I say that, but it also depends, right? I don't even know if I've got an example right now off the top of my head because like I haven't done anything with outside of vehicle controls in so long right now. I think I've got something. Epic launcher. Library. What's up, Chrono? Yeah, like we could come to here, right? This is the double jump one. Yeah, probably this one. Just meh. Why just meh? So what part of the character system is confusing, right? The USB key for my server died. That sucks. Wait, were you running an entire server off of a USB key? That's kind of badass. I've thought about doing stuff like that, but never got around. Unraid leads it all in, loads it all into RAM. Oh, that's fair. I think TrueNAS does the same thing. Like it's all loaded into RAM. So like the TrueNAS minis, I think have like effectively like an SD card or something like that for the operating system, and like it loads up and just reads from it. There's very little writing to it. Yeah. So it makes sense, right? Like it's low write, so it doesn't matter. Low write, you don't need a ton of storage for it, so yeah. Sorry, I'm getting some Unreal questions real quick here. Okay. While this loads up, I want to continue with this tutorial real quick.
It's too much more than just cameras. Cameras are kind of the main example, but there are a bunch of other things that don't yet have its DOTS equivalent yet, such as like particle systems and different types of renderers and things of that nature. So we're still going to need to have those things attached to a game object. And then the best way to kind of fake the behavior, if you will, is to basically just sync the transform of that game object with the transform of that entity so that everything kind of looks like it's happening correctly. Now, I know there are a number of ways to actually go about implementing this, and so what I'm going to be showing you today is kind of what works best for me. If you do know of a better way, or maybe how to improve my method of implementation, definitely let me know down in the comment section below. Also, if you did find this video helpful and you learned something, I really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos on the entity component system and Unity's data-oriented technology stack. And if you do want to download the project files from today's video, you can do so using the link down in the description below. Anyways, let's go ahead and jump on into Unity. All right, so
hybrid render. We don't need a hybrid render. No, I refuse. Oh, that's not what I wanted. Oh, damn. Wait. It doesn't have just the files? No, the files aren't here. Oh, well. I think I know how he's planning on doing it, but this is also 4 years old, so it's probably out of date. Where did I put I think I stashed it in here. I just left it in here. Of course, this one doesn't have it because it was the double jump tutorial. The double jump didn't actually need anything to do with with that. That's so good. Okay. I forgot about that. Wait, where's the coin pickup thing? This one should have something, right? Do fastest way to add follow camera using do camera system in Unity. Dots camera. This 1 year's old.
Hello
Yeah.
everybody, welcome to today's video. I just want to give a little bit of an overview / review of a fairly new DOTS asset available on the Unity Asset Store, which is the third-person camera for DOTS, developed by Thomas Enzi. I'm not going to say his last name correctly, so we'll just stick with Enzi. You may have seen Enzi's profile picture if you've browsed the Unity forums, especially in the ECS forums. He gives a lot of helpful advice and information over there. Also, he has created another third-person camera asset, which is available on the Unity Asset Store as well, which is just for regular Unity. However, this is the DOTS version of that, so we're going to be taking a look into that today. Now, full disclosure, the developer of this asset did reach out to me directly to provide me this asset free of charge. However, it didn't come with any expectation of creating a review on it or anything like that. It seemed like he really just kind of appreciated my content and wanted to give me this asset. And since then, I have been playing around with this asset a little bit, and I just wanted to share with you all because I do think that it is overall a really good asset and something worth looking into if you're making any type of third-person game that can use a camera like this. Now, real quick before we get into the review, I just want to point out that right now through December 6th, the Unity Asset Store is hosting their Black Friday.
God damn it, I don't think I have a project in Unreal that I can just spin up right now. But what part of the character system was not working for you? This requires something to be installed. Double jump won't work. Action roguelike, no. Could do, no, it would be this one, but then I'd have to upgrade because I don't have 5.3 installed right now. Fuck, I wish I had 5.3 installed right now. I thought, yeah, I cleaned house a little bit here. Well, we could just make a project. Won't take that long.
Friday/Cyber Monday sale, which is kind of one of their big.
I don't want to pay for a camera system right now. Had a hand of cameras in ECS 6 months ago. Works for me.
Hello Play4Jess. In today's tutorial we'll learn how to implement the camera so that it can follow player transform from within the ECS code. So let's dive in and see how it's done. First, let's add the Cinemachine package, as I want to use the camera to follow the player. Let's go to Window, Package Manager, and search for Cinemachine. Download the package.
Chrono, is Cinemachine really just the way to go? Like, is the base camera system that bad in Unity? What's the deal with Cinemachine? That was great. Machine is a suite of modules for operating on Unity cameras. Operating the Unity cameras. The machine solves the complex mathematics and logic for tracking targets, composing, blending, and cutting between shots. It is designed to significantly reduce the number of time-consuming manual manipulations and script revisions that take place during development. Good. Yeah, but it seems like it should just probably be the default camera, right? Like, am I crazy in thinking that? Like, it feels like it should just be the default camera at this point. It's like, what do? You start by installing CinemaCam camera. All right, so we need CinemaCamera, right? Wait, no, it's this one. Camera. There it is. Cinemachine. Oh, welcome back. So I need Cinemachine. You're saying, right? Let's install it. We're gonna remove the Dots character controller because we're not using that anymore. We built our own. Might create a game to see how far I push the learning process. Making a game, no matter how small the game is, making a game is the best way to learn the engine, right? So like I've been doing Unity now for this is my 3rd week of Unity, right? And my 3rd week of C#. Have you tried to creating a simulator of any kind? Not really, because like I don't really play a whole lot of simulation games, right? Like the really hardcore simulation games, or are you talking about just like generic stuff? Like I've played around with the vehicle controller systems or the vehicle systems in Unreal, and like just running around. I built a mech system at one point. It's a mech system that feels like a third person controller though, because I'm not really a tank mechanics person. Like I don't like tank controls. I don't know. It kind of depends on what you're looking for, right? But what kind of game are you looking to build? Because like depending on the type of game that you want to build, Unreal might not be the right choice unless you really have a reason to use C++. Or Unreal specifically. But 3rd week in Unity, how it feel compared to UE? I miss Unreal a lot. There are aspects of Unity that drive me crazy, but there are aspects of Unity that I kind of like. But I'm switching like I'm experimenting with Unity for the sole purpose of that Unreal is currently incapable of making the game that I want to build. It will be in the future, but I don't know how much time it needs to do it, right? Yeah. So like UE is great. I really like UE. My test project. So like the things that I miss about UE are like I miss the camera system, and I miss that their their default physics system for the entire game works within their entity component system. I really miss that. I miss that so much. I really, 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 really wish that Unity didn't restrict that. I also don't really like the idea of like the sub-scene system in Unity that sorry, I really don't like the sub-scene system in Unity for the dots to add things to dots. I just think that it should work. Got a story-based game in mind, but I might try my hand at an RPG to get a handle of things first. That is not the way that you want to do that. There are so you want to build a game quickly, right? So so you want to get started in game dev, right? And you don't want to just spin your wheels for like the next 4 years, right? So if we have like here we let's have these like little pillars, right? Like actually let's just do this. We'll do this. This will be time. And then this will be RPG. Right? This will be like a shooter. Right? Uh this could be like a platformer. Right? RPGs are very time intensive. Incredibly time intensive, even for small RPGs. This RPGs are the most time intensive things possible. Shooter? Not even half probably. Like you could build a shooter in a month. Is it going to be a good shooter? No, but you can build a shooter in a month. You can build a platformer even faster. Again, is it going to be a good platformer? No, but you can build it. You should start with like something at this level, not this level if you want to learn. Right? So there are aspects that you need to work out for an RPG. But the big thing about an RPG that's going to be intense is one, what style of RPG is it, right? Do you have a full like your combat needs a lot more math, right? What do you need to figure out your like how do you get into combat and stuff like that? You need an entire story for an RPG, right? That's really what makes these painful. Like not painful, I mean like very large games. You could also do like effectively like a Diablo clone, right? Where it's going to be a little bit harder than a shooter, right? This could be like a Diablo clone, like a D2 clone, right? What you do is you strip away all the story. There's no story, right? And all you have is you've got enemies that spawn and attack you, and you have whatever your combat system is, right? And then you work that out, right? Or you effectively like you've got your character, he runs around, right? Or they run around, right? And then you've got one or two characters that you interact with for maybe some tertiary dialogue that's not super important, but it just is there so you can get used to putting that on screen, right? So like you don't have to do a shooter, but you could do like a D2, D3, right? Like a dungeon crawler system, right? But like not a full fat dungeon crawler, right? Just like a stripped down dungeon crawler where it's like I have character, they run around my really small map, right? And endless swarms spawn in from different directions, right? And whatever my combat system is implemented. There you go. This is a good game to start with. Something like this. It could be top down, it could be third person, it could be first person, it could be, top down and then combat goes into a different scene altogether. Like there's a bunch of different ways to implement this. Right? You have to solve all the problems. And then and then like maybe after a certain amount of waves or something like that, you go back to town and you've got a couple people that you can like chat with, right? Yeah. So the idea behind this isn't to build a game, like a game, right? The idea behind it is to build systems that teach you the concepts, right? Like this game doesn't need to have this game here doesn't need to have anything to do with like you don't need to have any inventory system, right? You could have pickups that just affect stats, right? And stuff like that. You kill things, you gain experience, you level up, whatever. Like you don't even have to have that. You could just have them drop things and pick them up and it's like +2 to attack, right? Like the purest sense of the gameplay loop, right? This is like the most basic gameplay loop possible. That's what you want. So you build that and then you iterate on it and you iterate on it and you iterate on it. Or you build it and it teaches you something, then you go back and you build a different game. The more games you build, the better you're going to get faster. And when I say the more games you build, I do mean like fully actually like a prototype, but you actually want to produce a game. You want to actually put it up on a website that people can download, install, play. You want to do the entire process of building the game. You want your start menus. You want your main menus. You want proper loading screens. You want gameplay settings. You want, controller update settings and stuff like that. You want all of that, right? You just want the game to be really tiny, right? And then you put it up on like itch. There's no need to like spend $100 to get on Steam. Also, sup Rush. Check it out, Rush. I got this the truck working a little bit. So you can turn the wheels and the wheels move when you apply gas or brake in the correct directions. I also fixed the problem of you whipping around. Going up hit my brain like nice way. Yeah, no, it's beautiful. The suspension's still a bit longer than I want, but yeah. It's beautiful and it works, and that's the important thing. Whee! Fucking ads. Whee! Right? Yeah, it's beautiful. The sound is shit for ads in Spanish. It's good to know. Whee! Look, he's hunting. The cat is hunting. Meow. No, it's literally just static meshes. It's 5 static meshes. So the wheels are static meshes that have no collision. And then you've got the actual body of the truck, which is a static mesh and by itself, and it has collisions. And then you apply a force to the to where the wheels are in an upward direction, and that's what gives you the bounce. Wait, which direction did I go over there? Yeah, no. It looks it's finally actually working, right? Just driving circles. We haven't finished. I've got to get the camera going. Once the camera's following it, we can add actually I should probably add the ragdolls before the camera. That way we can just test the ragdolls, where it's just like it runs over the that was cool. Wee. I was thinking the exact same thing, but that's up to Aku. Aku's the one actually doing the truck, doing the truck. But I love that hop is fucking great. Wait, which direction do I need? This direction. Here we go. I wonder if you can do it forwards. No, not really. You have to do it back. You have to do it in reverse. Wait for it. Because we have more power reverse. There we go. I love that hop so much. That hop makes me so happy. Now we just need like you said, cat ears and everything. The hop is great, right? The hop is amazing. Whee! I wonder what forces are making it do that though. One sec. Let's go forwards and get the good hops going. Whee! And the truck system, too, it's something like Tony Hawk game. I was thinking that exact same thing when I first saw that jump. That jump was just like, oh, this feels like a skateboard game. Wee. Wee. But you can only do it when you're going backwards. You can't do it forwards. I think it has to do with yeah. I think that needs to be in the game though. This I think that that's something that I want now. I want to be able to hop the truck. Whee! I feel like we should be able to do it in forward too. And I think I've got enough info that I can like I've got a custom enough system that I can actually pull it off. Trick kills. I was already thinking about that before. Thinking like boosters and stuff like that and ramps. Fly off a ramp into people. Fucking plow through them. Triple kill. I'll be right back. Okay, I'm back. Sorry about the wait. Oof. Yeah, Aku's doing the truck, so like he's doing the truck, so I'll have to pitch the idea to him. You find out the problem with the car bouncing? Yes, my dampening wasn't correct, but also the physics calculations weren't going to be correct ever. I think I figured it out, but I'm fairly certain that I have figured it out, but I also wholesale ripped off the what was it? It was the Trust and Open. It was the ECS network racing sample. So I took that and then I proceeded to rip out everything to do with networking and only bring over the parts for the vehicle. And then start tweaking it. Yeah. But now I need to do the ragdolls. Which means I need to open up the physics sample. In the meantime, you want to see the truck? The truck's so much fun to drive right now. I think this is the most fun version of the truck, but it is definitely not ready for prime time. So the wheels work. You can see they actually do spin when you apply gas or brake. There's no real torque curve, so it's just apply as much torque. Like you instantly get full torque at all times. So, but this is definitely the most fun version of the truck so far. But check this out. Check this out. Whee! Whee! Suspension on the vehicle is S2. Right? It's fucking amazing. 10 out of 10. See, did it open yet? It has opened. Okay. Let's see. There is the Ragdoll character controller. It's not that. Planet Gravity. Joints and queries. I think it was under here, right? Yeah, here we go. Ragdolls. Actually, it might have been single Ragdoll that I really wanted to play with, but actually, let's take a look at that one. Single Ragdoll. Don't save. Yeah, it was this one. Okay, here we go. And the built-in physics does nothing. Why? Because dots. Okay, so the project's open here in third person for UE. What were your UE questions about the character? See this one and this one. Split. Okay, so we can do this, and then we take a look over to here, and we can see the Ragdoll here. This is a prefab, so if we go to the prefab here, we can open up the Ragdoll. Character joint, rigid body, capsule. Did they have to build this themselves? Is that how this works? There's a physics material. Torso? Character joint. Do we have that for our characters? No, we don't have a mesh. It's okay. I think we still have the mesh around here somewhere. I just got to pick one of these characters here. Right. This is a mesh with a mesh renderer. That's not what we wanted at all. We just want one of these. There we go. Not the free time one. Let's do this one. There we go. There we go. Now, if I remember correctly, she has. We did the whole like. Did we not keep it? No, no, she doesn't have any of her collision bodies. No. I'm so sad. She's gone. We have to do the rigid bodies again. Assets. Edit. What was it again? It was ragdolls. Unity ragdoll. No, you can Archie 3D objects ragdoll. Okay, that's what it was. Let's open her up. We're just going to open. It's not what we wanted to do. Okay. So we just do this and then we do 3D objects and then we do ragdoll. And pelvis is not being set. That's fine. So I believe that it's the hips. Yeah. Go for the hip. And then it is. And for the. It was this one for the left leg. And then the lower leg. And then the foot. And we can do that. And we do this. And it is upper, right? Yeah. Lower leg. And then the foot. There we go. Then we want pelvis. Middle spine is this one. Neck, and then this has head. And we want the shoulder, which is actually the upper arm. And the lower arm is the elbow. And then we're going to do the same here, upper arm. And then the elbow. And then our total mass, I think this is in kilograms. Average weight in kg of a Japanese woman. Right, we're going to just go 60. There we go. And then if we hit play, does she just fall? Wow. They are overrides. That's 10 out of 10. What? There's our box collider, our rigid body. So what is the thing that we need to make this work? Back to the scene real quick here. Let's take a look at this rigid body here. Oh, it has a rigid body on the torso. That's what it is. Wait. We have a rigid body on the torso too. Rigid body on the torso. The head root also has a rigid body, which I think that we have a rigid body on all the ones that have stuff. Yeah, these all have rigid bodies. I'm not seeing it. It's the floor. Oh, wait. This is the right one, not the wrong one. Ah. We need... It has a physics shape on the floor, yeah. But do we have a physics shape on this? What's special about this? These look the same. Why is this not falling through the world? Rigid body, the character joint, and then a collider capsule? See, rigid body, box, that's fine. And then a character joint. These are the same things, right? I feel like I'm taking crazy pills. Okay, so we've got the upper chest. There's our box. Yeah. Nothing's different. We've got the character joint. Then what's the problem? Rigid body, the box. But she just falls through my world. And then this, the ground on the other one just has a physics shape and a physics body. Their physics shape and the physics body are the same. Yeah, this is effectively the same. Actually, I shouldn't say effectively. They are the same. Why is she falling through then? She is ragdolling, which is kind of nice. You know what? Let's take this. Yeah, this has the physics shape on it. Then we'll take her and let's put her over this and see if how she falls. She still falls straight through. Interesting. Why is she falling through like that? Let's do this and we'll do the physics. Oops. Physics debug display. Draw colliders. Huh. Shader mode. Why are you falling through my world like this? I wonder if I add the rigid body here. No, she still falls through. Yeah, it made it through. And Twitch won't let me actually take action against it because I can't see it on Twitch's side. Yeah. Yeah, that was cool. Why are you falling through the world? Stop falling through the world. She's ragdolling directly through the world, which is kind of cool. I wonder if it has to do with the ragdoll, if that's kind of the problem, right? But still, I'm curious as to like why she's just falling through. Because like if I open up this one here, this is set up like exactly the same. There's really no differences here. There's my torso. Let me double check. Hey, we found the problem. let's try to ignore that, you know. That is weird though, like what's going on there. So let's take this main camera. We're gonna move it closer so we can get a better look on her. There you go. What is with that forward motion there? So weird. All right, well, progress be made. To do. She does actually do the whole like debug. So debug, physics debug, physics debug display, draw colliders. Take a look at her colliders, and she does not move with them. Look how she's attached to the wrong spot. So this is ragdolling, but she's not because they're not attached properly. So I think I know what's going on there, and it has to do with like I have a feeling that this has to do with like animations. Because it's not up that the mesh isn't updating the updating with the stuff. So what we want to do, youtube.com Unity ECS ragdoll. Unity ECS ragdoll. So yeah, so this has to do likely with a lack of animations. Unity dots animations.
Hello and welcome, I'm your Code Monkey, and I've just published an update to my Unity Dots course. This one adds 15 new lectures, adding some bonus stuff on targeting and learning some more about the job system, and also importantly on building a custom dots animation system from scratch. This was really interesting to research and build. Animation is one of the things that is currently really tricky right now to doing dots. That's because there's no built-in toolset just yet, so you have to either use an asset or build yourself from scratch. Now in the course, since I provide the project files for every lecture in the course, because that I couldn't use any third-party assets, so we end up building it from scratch. It's a nice, simple animation system. It's based on essentially using spreadsheet animation except using meshes. So I just took some normal animations, I made a script to bake different parts of the animation into developable meshes, and then through code we just changed the mesh to create the nice illusion of some nice animations. Now importantly, of course, is making all of that work with dots, which is quite tricky because dots only works with value types, so we cannot have objects, no references, and meshes are objects, so actually storing that data was quite tricky. And also there are a ton of meshes for each animation. So once again, storing all of that data was also really tricky. That took quite a while to research, but I'm very happy with the final result. In the lectures, we're going to learn about how to use blob assets. This is a feature from Dots and allows you to have access to immutable data in a super fast manner, and it also allows you to have special blob arrays. So in the end, we end up creating kind of like a dictionary where we have an array of arrays. So the first array has the end.
That's this is some of the most depressing information that I've heard so far. So effectively he just said that like we need to get something out of the asset store for this effectively. Dots animation. This is like a possibility. But let me take a look at the ones that he put up here. So it was ECS Animations and ECS Animation Baker. So my query was wrong here. Oh, he republished for $120. Holy shit, that's expensive. Yeah, these are the two. Yeah, we'll take a look in a second. I was just hoping that like, yeah, dots animations. We can take a look at this. This one, the performance test. We can't use this one because we're not using like actual animations. We just need to attach the bones to the skin. Dots. Ragdoll. The issue with Ragdoll, like when you look this up, is that like it's not really there. There's not really anything there, right? View of physics and dots. Man, I kind of wish that I could use the Havoc stuff because like the Havoc stuff is like supposed to be really good.
Another one, animation system.
Yeah, oh, that's a classic one.
So yeah, officially the Unity Dots, their own animation system. That one is still, you can see it on the Dots roadmap page. It's under development. That's basically all that they've said about that official solution so far. So actually, yeah, I'll pull up the link to it. But I know Luke, who is in the chat, yeah, he's kicked off an awesome blog post, basically kind of detailing all the animation options that are currently available. It's a very helpful thing. I reference it all the time. I always get comments from people on the YouTube channel asking about Dots animations, and I send them that, and they're like, oh, there's actually a whole lot of options available.
Yeah.
As far as animation systems go, have you kind of used any in particular, or like what do you kind of typically do if you're implementing animations?
Generally, I tend to like switch a little depending on what I'm doing. My main approach is I use Mechanim, and then I on my Baker I store the actual game object that I want to spawn. That my Mechanim goes, and then on initialization of that in runtime, I just go ahead and instantiate that game object. But it also means that because I am in my entities where it's doing that instantiation, I can also get that reference on the entity itself, and I can kind of hook up all my animations directly to my entity. So if I want to play an animation, I can just say, set trigger or something on my.
Right. So yeah, basically just to kind of confirm what you're saying is you have your entity, and then you have like a Baker with a game object field on there. Now you're not, during the baking process, you're not converting that game object to an entity. You're just saving that game object reference, and you put a prefab in there, right? Like a prefab game object.
Yeah, exactly.
Yeah. And then so at runtime, basically.
Let's try something here. So on the hips, if I add a physics, is it a dynamic material? Is this under physics? Maybe it's under entities? This is on the torso. See, I'm not even entirely sure if it's actually if it's actually animations that I need so much as I just need to affect the bones. Right? I was kind of feeling like this might be the way to go, but I don't know if this is it. This is just a shader, right? Yeah. Okay, so that doesn't matter. Surface input. So if we have some way of directly, here's the mesh, all mesh. So this mesh is not affected by this, right? So like if I take, let's say we take this, one of these, right? I don't think this will have any direct, oh no, it does. Interesting. So this is skinned for that, but it just doesn't want to. That's so weird. I'm not sure how this needs to work. But we can see that the legs here, yeah, they crumple correctly. But crumpling correctly isn't really what we're looking for necessarily right this moment. We want it to like fly, right?
You'll instantiate that prefab, and then basically you can now have a reference to that through a managed data component, right?
Yes, exactly.
Yeah,
you can even actually add managed components are both all iComponent data that are of class, but it's also all Unity engine objects. So that also includes animation directly. So you can just actually add the animator. So if you on your game object have an animator component on that game object, the prefab that you made, and you can just go ahead and add that animator to the entity.
Unity, ECS, Ragdoll. Combination of active Ragdoll. We don't care about active Ragdoll right this moment. Dynamic Ragdoll example Unity. Requires ECS. Get component colliders to work with animation system. Fortunately, the system is still under development. Did have this, right? Current best way to handle animations in ECS. Okay, here we go. Pure animations. This approach uses a framework for animating meshes using ECS components and systems. It will support a lot of advanced animation techniques and features, and its speed will be very fast compared to traditional game object-based animations. 100K entities is possible in the right circumstances. Several people in these forums and on TMG discussed having their own dots animation package. Let me know if I'm missing any of these. Okay. Animation is probably the most well-known animation package, and it was built by our very own Dreaming LM Latios. You will need decent understanding of animations /bone/skin mesh and dots to use it. It supports a lot of badass things like weapon bindings, deformations, bindings, and more. It will be very fast, not as fast as the GPU approach, but it is arguably the most flexible and powerful. To do GPU skinning, GPU bone animations. This technique involves using skinned meshes and baked bone animation data to perform skinning in the GPU instead of on the CPU. It is combined with GPU instancing. This method is extremely fast and supports 100K instances if the circumstances are optimal, such as the use of LODs. The downside to this approach is that it's not easy to get things like weapon bindings working, and the authoring workflow will be more involved compared to the hybrid approach on a pure ECS package. Also, you're probably not going to find fancy features such as inverse kinematics. There is a discussion on some of these techniques. Amistro, who can be found lurking in the TMG Discord, built this animation package that uses GPU skinning. It has graphical animation state controls and is a getting started tutorial. I believe it supports animation bindings, but I'm not sure if it can do weapon bindings. And it is an offshoot of this GPU skinning by Hmm. The legendary Joshim was one of the first, if not the first, to build a library via this technique. From the Node.js demo. The repository hasn't changed in about 3 years. However, there is a bunch of updates. There is a bunch that update it to. It uses a certain API call that has been deprecated, so I never got it running. That's poopy. Crowd animations. You can get this from the asset store. It supports blend animations and can be used. Mechanic animator. The author told me that it should work in dots. Vertex bone weights are baked into UV channels of the mesh, and bone transforms are baked into animation textures. It has some unique features such as blend sampling, animation transforms, and LODs. I have only seen one tool that uses this technique. So this is runtime static mesh replacement. And it is an asset in the store called Mesh Animator. I believe it works by baking a bunch of static meshes and then swapping them out really quickly at runtime. So you get the benefits of batching and instancing. I suspect this technique is not as fast as the GPU method, but it would probably work even on ancient mobile devices that are unsupported by a GPU technique because it bakes static meshes. Because it bakes static meshes, and it probably uses a decent amount of memory and won't support lots of fancier animations. This approach, okay, so vertex position baking. This approach involves baking vertex positions into a texture as opposed to GPU skinning, which bakes the bone position. I believe that it will run faster on a GPU, faster than GPU skinning, because with baked positions, there is no transform hierarchy to multiply. Even without LODs, you can pull off over 100K instances, but as always, there is a trade-off. All the techniques, this one is the least flexible. First of all, the textures are big and use more memory. Can be mitigated with compression techniques. Secondly, features like weapon bindings, animation blending, etc., would require some tricky hacks, so they're not supported. Don't underestimate the power of a simple movement script. You've all seen the dots rotating cube demo with millions of entities with a few simple ECS systems for position, scale, rotation, movement, and occlusions. Using skin and collision, you can put together. I kind of want to take a quick look at something here. This is going to be fast, right? So we do this. We see her fall like that, right? And then we just grab this bone. Right? Let's go to runtime. Okay, so what we want to do is we've got the head, I suppose. Yeah. here's the mesh. The mesh has no bones, right? So what happens if we move? What happens if we move this? Let's go up. Nothing. What about the hips? The hips are important because the hips are like the most important. There we go. I think she's still just doing the whole T frame. The still doing the T thing, right? So if I hit play and then back that off. Yeah, she's still T'ing, but I wonder if I can associate the if I can attach the bone itself to the capsule, right? And then we essentially just be like, hey, if this one's ragdolling, then enable this script, and if not, just don't worry about it, right? And I think one of these is doing that, and I have a feeling it's mathematics here. Movement and using skin and collision. You can put together some interesting animations. There will be lots of things. Although, like, so this is one of the GPU ones, right? Okay, so this doesn't state whether or not it supports what I need. This does state that it supports exactly what I need, which is the dynamic bounds. Entity physics simulations. No, this will not work in mono or with mono behaviors. These systems only work with ECS dots environments. To use with animations, you will need third-party solution, as Unity does not provide any ECS animation packages for 1.0. Okay, so that's $30. Sprite animations. This one's cheap. This one's unbelievably expensive. And there's this one. So this one we know will work, though we don't know about the quality. It could be good, it could be bad, right?
This video I'm going to be actually showcasing my dots animation system, which pretty much runs off of that animation system. If you saw that video, then you understand what I'm talking about here. If not, go check out that video for sure. But let's get right into it. So first, just make sure you download the package, and we'll start a new project. We'll just do a 3D sample in URP, and we'll just name this dots issue text. All right, all that makes sense later on. So here's the scanner. Here you can use the demo scene. We'll check that out. So we go to the player.
One sec. I think that it might just be worth asking here. Actually, wait, no, I'll ask in the Unity one. Yeah, here. Jump to present. There we go. A bit stuck with figuring out ragdolls in dots. Does anyone have suggestions for start or a good package to look at?
Here, so light. Now on this object, we have to control that. You see, it'll start running. Right now I'm getting some entity errors, but it's not being my code. I'll just downgrade the version. But as you can see, the animation's running. There's nothing over here. And if we want to go to the hierarchy here, I'll take a look. And you can see here's our created entity, mesh that you're referring to, and animation based on animation control. So this is going to be pretty much what makes the animations and the sampler. It's just going to be the base prefab of the object that you want to instantiate. Download this package. It is on my Patreon. So
Dynamic bones. I thought I opened up that one and I was taking a look at that. Damn it. Does it actually state that it handles ragdolls? Damn it. If I remember correctly. Ugh. Okay, so somebody said that this one actually does ragdolls. Multi-label, motion speed multiplayer, motion timer, or cycle offset. If this does it, we might just have to do this. Well, this one was definitely updated recently. Yeah, January. Last release was the 22nd of January. Free physics sample repo, ragdoll scene. You are willing to purchase. It's like here. Come over here. So yeah, I was playing around with the ragdoll scene, but it doesn't implement a base mesh. So the bones on my mesh don't bind to the collisions. Bye. As I know that. I think it was this guy, yeah. But it sounds like it doesn't say anywhere here that it supports ragdolls, but it does say optimize for deformation system. So that might be it, right? Once shapes do non-skinned mesh animations. Render bounding box. Recalculation. Can recalculate animated skin meshes. Mesh renders bounding box from skeleton bone pose to enable this for a particular skinned render mesh. Just enable when off screen. This sounds like what we're looking for. Bone attachment. Visuals are looking. I recall reading about ragdolls in the docs in V1. Not sure how easy / hard it is to implement. I know is often around here on his Discord if you have questions about this feature. Maybe he will show up with the bang. So apparently this guy actually chills in the Discord a lot, so it's on the store page. Did I not see it on the store page? Oh, you mean his Discord, right? Oh yeah. The release was last month. The latest release. I thought I already said that it came out on the 22nd of last month. Yeah. No, it's a good one. Give me a second here. Oh. Oh. I have the sample scene. One sec. Here we go. I have the sample scene particularly to show this feature. Oh, cool. Dope. It sounds like it's the package I need. To getting started. he responded to me and said, yes, there we go. All right, let's see here. Oh, sweet. We have this specifically here. It has been added. Look at that ragdoll. So the answer is just this package. Right? And this package does come very highly recommended. What's this? GPU instanced? How well does it hold up with big crowds? How well does the animations? One sec. Let me see here. I'm having a conversation with this guy. Have you tested? I imagine you have tested it with large crowds. You can use handle the state machine. Do oh wow, this was like way back 1.4. Entity bone stripping mode needs to be configured again. Root motion. Inverse kinematic. Don't really care about inverse kinematics. Animator engine. Interesting. Legacy animator. Support status. Oh, cool. We can do GPU too. Optimizing bone entity count. So far, this actually seems like what we care about. Like, actually, this seems like exactly what we need. The only thing I want to verify, and I imagine that the answer is yes, is how well does this work for very large scenes? But I imagine it's good because it has the GPU as well. I'm like 80% there for I'm just going to buy this. Does it have any reviews? Oh, it does. Still experimenting and learning, but there's almost no animation engine involved. Performance will be limited by physics simulations on the CPU. Very limited ragdolls. Need to do ragdolls when they enter a trigger box. Outside of that, it's mostly just a base walking animation. Ragdolls when they're entering a burger box. Outside of that, it's mostly. Ah, this is getting to getting into the good stuff here. Would I be able to toggle off the? I was thinking maybe a tag with a toggle to turn on / off ragdolls. And outside of that, just do normal animations. Actually, I should probably have just done this. It kind of seems like that should work. Yeah, look, it works really well with crowds. Okay. We've effectively got all of our answers. The only thing that now I'm worried about is whether or not we can do selective ragdolls. Like effectively no ragdoll, and then we do ragdoll only when it's required. But I think based off of my limited knowledge of ECS, that should probably the dot system that should probably be doable. Like we're not doing anything particularly special there, right? Like we do have a little bit of specialness, which is like the give me everything is doable. It's true, everything is, but like whether how much work it's going to be is a different story. It does seem though that the answer here is to straight up just use Rukhanka animations, and then it will cover everything we need. I'll be right back. I'm gonna grab myself a drink and something to munch on. So as expected, physics operations are done on the CPU, not the GPU. Ooh. See, thanks for the reply. But are the contents of the patch already to 2.0 without applying the patch? It looks like the mesh deformation system already calls var workgroup size X. I'm sorry, wrong patch link. Okay. I got myself a Yukon cookies and cream ice cream sandwich. They will be able to use GPU for physics. I have seen some people do it. Nice. Yeah, I think Havoc might use GPU for physics. It's just there's a lot of information that has to go to the GPU in order for physics to really be calculated, right? It's mostly the collision stuff, right? Phone entities can drive animations. Ragdoll sample have very simple pre-configured ragdoll physics ragdoll. When animations are not played for animated entities, physics simulation will drive the animated bone position. Oops. If I'm reading this correctly. Ragdoll sample has a very simple pre-configured physics ragdoll. Okay, so here we go. So if I'm understanding correctly, then it sounds this only has one L. Yep. Sounds like I can do crowd sim, do the Formant crowd animations. And then when X or Y happens, switch to Ragdoll Sims on that entity. Okay. So, effectively, what we've learned is that we're going to add this to cart and come back to it. Hmm. Hmm. Yeah, effectively something like that. You can even animate your crowd using using GPU animator, very performant. Then when you enable physics for required rigs, switch to CPU animator and continue with ragdoll simulations. Oh well. Well, well, it sounds like I'm going to have to make a. Well, it sounds like I'm gonna have to make a purchase. Hmm. Hmm. You need 6, right? Sweet. Sweet. Okay. So the answer to my problem is just buy this. All right, so let's get back to the camera. This is something that like I would worry about building it myself, but like it's not really worth it. I've now heard from like I was suggested this guy's plugin from 2 different people on the Unity Dots Discord. The guy answers questions really quickly. It has really good reviews on the asset store. It's suggested by I think a couple different YouTubers. So, and he keeps it up to date. He's very active. I'm like this is like literally me on the Discord having a conversation with him. Like he's the one that's answering my questions right now, so so yeah, it's perfect. It sounds like this will work. Now we just need the camera.
Hello everybody and welcome to today's video. We're going to be doing pretty much ever since I started talking about Unity ECS on this channel, there's been one topic that people have requested more than anything for me to make a video on. Does anyone have any guesses on what that might be?
Where was my camera? I had a camera thing, right?
Hello and welcome. I'm your
I
Code
think it's this
Monkey.
one. I still don't like that I'm gonna have to drop a bunch of money on this, but whatever.
And here, let's build a really nice. You can see the player is on system. We want the ability to.
Okay. Hello everybody and welcome.
We did that already.
But hello everybody and welcome to today's video. We're going to be talking about using the.
Did that already. This was the really interesting
So, to recap.
Yeah, okay, we can come back to that.
So just a few weeks ago, Unity released Experimental Entities 1.0, which is the long-awaited 1.0 version of ECS. And in that, there have been a lot of significant changes since previous versions, pretty much ever since.
Hello and welcome. A while back, Unity introduced a new feature.
We'll come back.
Hello everybody, hope you all have been having a wonderful holiday season so far. Now, as we begin to close out the year 2021 and head into the future, I have a lot of really exciting things planned for the Turbo Makes Games YouTube channel. Hello everybody, and welcome to today's video. We're going to be talking.
When I started out, the math involved
compression ratio.
Don't need that anymore.
Okay, so here our code is done. So we have a for.
Leaving that. Don't need this one. Don't need that. This is literally the one that I was just.
Here is an editor error which you can ignore. So let's create a virtual camera. Right click in hierarchy, scene machine, virtual camera. Let's reset transfer and change.
Okay, I'm fairly positive that I did the thing. So and close this. There, close that. And close this now because we don't need it. We now know that we will be not using that. So that's fine. Here we go. I want this to be authoring. And this one's the inspector. Yeah. Okay. So we go to here and we're just going to remove this. Remove component. There we go. Beautiful. Okay. So what we want to do now, should watch the monkey video on it. Okay. I think I've got the monkey video up. This one, right? Like the ultimate camera system in Unity.
Move, rotate, zoom in and out, enable edge scrolling, and touch drag to pan the camera. This is a great and very capable system for just about any game where you want the player to have direct control over the camera. You can follow this tutorial and download the final project files. We're going to build it in a 3D scene, but in the end I'll also quickly show a conversion to make it work in 2D. Now this video ended up pretty long, but it's the only video you need.
No, I do not have the right one.
This video is sponsored by Unity. In this video we're going to look at Scene Machine in Unity. This is an excellent feature that lets you easily control your cameras with tons of options. Scene Machine is great for gameplay and also to handle cutscenes. Let's begin!
Oh, this is his old one. Yeah, okay.
Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so Scene Machine is a camera system that gives anyone working with cameras the ability to create complex behaviors without having to write any code. So if you're an artist, designer, or just someone who wants to make a short film inside of Unity, then Scene Machine is exactly what you need.
Oh yeah, wait. Oh, that's the important thing. Just give me a second here. I just got to respond to one of my buddies. You will be heavier for older systems, but more performant if your system older systems, but they're long term. But Unity will allow us to target older systems. Unity will allow us to target older systems. Wider install base.
Here we're going to look at how Scene Machine helps us very easily set a target for our camera to look and follow, play around with values to make our camera work exactly as we want it, set up multiple cameras and smoothly interpolate between them, and in the end I will also showcase how Scene Machine also works in 2D. Now this video is an interesting one. What I'm going to do here is essentially a smaller video version of a Unity Learn Premium course. So if you like this and then want to learn more, you can check out the entire course as well as many others by clicking the link in the description. Unity Learn Premium is currently part of the Mega Bundle sale going through March 31st, so you can get 1 year of Learn Premium along with $1,000 worth of assets and tools for 90% off. Unity Learn Premium is designed for those who want to accelerate their Unity skills with advanced learning content. There are over 350 hours of learning content on the platform, including a 15-hour course on using AI in your games and a 22-hour course on mastering C#. So if you've been meaning to look at Unity Learn Premium, then this is your chance. For normal price, you can get it through the bundle alongside tons of awesome assets and tools. The link in the description.
Fucking master C#.
is also an affiliate link, so if you pick up anything through there, you'll also be helping out the channel. So check out the Mega Bundle Sale, get some awesome lessons and tools, and check out Unity Learning Premium. Thank you to Unity, and thank you to these awesome supporters for making this video possible. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free forever. Okay, so as I was saying, Cinemachine is all about making complex camera movements simple. Cinemachine does not replace your normal cameras, but rather it works on top of them. So you have a brain and a bunch of virtual cameras. Then those virtual cameras can be animated, move around, and do anything you want. You can make them follow an object, look at something, and cut or blend between different virtual cameras. The brain processes all that data and creates the final shot. Here I will demonstrate Cinemachine mainly working in 3D, but everything works exactly the same in 2D as well. Alright, so let's start using it. So over here I am in a basic scene. Over here I have my basic player character, and I can move around this nice small map. And as you can see, the camera right now is on a completely fixed position. I covered this character controller in a previous video. All I did was change the Y movement for Z movement, and just like that, now this character is moving in 3D. So we have a nice demo scene. Now let's use Cinemachine. First of all, we need to add it to our project. So open up the package manager, then scroll down until you find the Cinemachine, and click on Import. Just like that, Cinemachine is now added onto the project. You can confirm that it was installed correctly by checking all the way up here that there's a new Cinemachine menu. Alright, so with Cinemachine installed, let's start adding the main component, which is the brain. The brain is the component that acts as the main hub for all the other Cinemachine components. So it takes control of the camera and then allows you to work with various Cinemachine virtual cameras. So let's select our main camera, and then we're going to add a component. And then here we go into Cinemachine and add the Cinemachine brain. There's the brain component, and as you can see, there's tons of options to customize it exactly how you want it. But for now, let's leave everything at the defaults. And now that we have our brain, we need a virtual camera. The virtual camera is what actually defines the behavior of our camera. So let's go up into our menu bar. So click on Cinemachine, and then in here, create a virtual camera. Once you do, you can see a new game object has been created in the hierarchy, and if we inspect it, we can see that it has a Cinemachine virtual camera component. And over here, as you can see, we have tons of options. Now, if you've ever manually worked...
I think virtual camera is required to get it into ECS, and that's the only way to have it as like an entity that reflects. But I think the idea is that the entity grabs the camera, and then the camera is pushed to, it just updates to wherever the entity is, right?
With cameras, then you know how it's quite a bit tricky to get them to simply follow and look at an object. In here, all we have to do is set these two fields. So over here I have my character in my scene, and I want this virtual camera to always be looking at it. So to do that, just drag the character controller onto the look at field. And just like that, you can see that our virtual camera immediately snaps onto our target object. And just like this, if we try to play our scene, and if there it is, the camera is pointing towards my character, and as I move around, the camera correctly tracks my character. Alright, so here you can see by just setting a simple field, we have our camera correctly tracking a special object. Now over here, the virtual camera has tons of options that you can play around with. For example, over here we can click on the aim tab in order to expand it, and here we can play around with any of these values. Now the main thing is the ability to add a dead zone and a soft zone. So down here we have the dead zone width and the soft zone width and height. Visually we can see some nice helpful gizmos. So as I increase the dead zone width and increase the height, and there you go, you can see a little rectangle right in there. So there's an area right down the middle, then one outside of here, and another one way out here. So the middle one is the dead zone, then this one out here is the soft zone, and then out here it will never reach. So once our character is inside of the dead zone, then the camera will not move at all. So as I move my camera in there, as long as I stay in there, the camera does not pan, does not move, does not do anything. Then outside we have the soft zone, and as soon as my character moves into the soft zone, there you go, the camera now moves around in order to make sure that it's always looking at my character. Then here we also have horizontal and vertical damping. So right now it's falling pretty fast as soon as my character moves, and if I increase it by quite a bit, then all of a sudden it won't track the character, but it will track it much slower. Then the red area is the end of the soft zone, which again we can still modify here. And that means that as soon as the character goes outside, our camera won't track it instantly regardless of the horizontal damping. So as I move away, and yep, there you go. As soon as I go into the red area, it starts falling instantly. So you can see how just by dragging a target game object and setting a few options, we already have some pretty complex behavior. Now over here, the other field that we have is the follow field. And with the follow field, we also have the body in here that we can set all of our options. So for example, let's drag our character controller onto the follow field, and it instantly snaps right in front of the character. So then here we have the follow offset. So let's put it up. And again, the camera is always pointing towards the character. So let's put it and push it a bit away, just like that. So with both of these, now our camera will look at the target and follow it. So he's right in there, and as I move to the left, you can see the camera panning to the left, panning to the right, moving forward and moving backwards. For example, let's slow down the movement speed, and let's increase the horizontal damping on our look. And now if we move, yep, there you go. You can see that he follows, and he goes just like that. So as I move away, the camera is rotating towards it, and then slowly moving in order to go onto this perfect follow offset position. So again, here we have some pretty complex behavior without having to write any code. Although obviously, if you wanted to work with some code, you could still do it. For example, you could easily swap out the target look at with a different object. So you know the game's running.
Okay, so that does actually do, like, it sounds like it just does exactly what I want.
Each doing a query on everything that has a local transform, and this code.
Oh, this isn't it. Where was it? There was one that was specifically for dots. Did I navigate away from the dots one? That might be this one. I thought I had a dot specific one. Unity dots camera.
We need to learn how to set up scriptable objects and how exactly to best store the data for each type. And this update also includes a very important lecture on polishing the animation system that we made in the previous update. We need to learn how to make a custom baking system and create additional entities in order to make sure everything works perfectly. So if you're already
the data that is going to store our final position for the camera. Since this is a position, we'll need a float 3. In the scene view, we do not see the entity movement, but we do see the gizmo moving. If I select the player entity, I should be able to adjust the height of the offset using the parameters in the inspector. This is the position our camera is going to rotate around. It will also be the position. Next, we'll deal with rotation Y, which will be our horizontal rotation. I want to check if this is bigger than math.pi. We'll want this to be for the full circle, so we'll multiply this by 2. So if rotation.y is equal to math.pi times 2, we'll subtract
One sec. Unity Cinemachine. Follow camera. Unity dot Cinemachine follow camera. I'm using dots Unity physics to simulate. I updated the last. There's no support for dots physics in Cinemachine, as far as I can tell. So if the target isn't using physics, game objects, regular physics, with rigid body set to interpolate, then it's likely that this will always stutter. You should assign Cinemachine to follow a target so you can guarantee the smooth updates. I moved this in Cinemachine form. I moved this to the Cinemachine form because it doesn't look like it's a dots issue really, but simply that there's no built-in support for Cinemachine. I doubt it's even a bug.
Hello everybody and welcome to today's video where I'm going to be showing you how we can follow entities using a Unity camera or the Cinemachine in Unity. Now when I say entities, I'm of course referring to this in the sense of the entity component system, which is part of Unity's new data-oriented technology stack, which doesn't yet have its own implementation of the Unity camera.
This is the one that I was thinking about that had the Cinemachine.
So we have to do a little bit of workarounds. So that's what I'm going to be showing you how to do today. Again, I'm going to be showing you how to do this with a traditional Unity camera, and I'm going to be showing you how to use the Cinemachine camera. And if you don't know what the heck I'm talking about with the entity component system, data-oriented technology stack, and all that, I definitely suggest checking out this playlist right here, where I go over kind of what these concepts are on a high level, and then I give you some tutorials about how to get started with them. Now, really what we're going to be doing in today's video is essentially syncing the transforms of an entity with a game object, and so this applies to much more than just cameras. Cameras are kind of the main example, but there are a bunch of other things that don't yet have its dots equivalent yet, such as like particle systems and different types of renderers and things of that nature. So we're still going to need to have those things attached to a game object, and then the best way to kind of fake the behavior, if you will, is to basically just sync the transform of that game object with the transform of that entity, so that everything kind of looks like it's happening correctly. Now, I know there are a number of ways to actually go about implementing this, and so what I'm going to be showing you today is kind of what works best for me. If you do know of a better way, or maybe how to improve my method of implementation, definitely let me know down in the comment section below. Also, if you did find this video helpful and you learned something, I really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos on the entity component system and Unity's data-oriented technology stack. And if you do want to download the project files from today's video, you can do so using the link down in the description below. Anyways, let's go ahead and jump on into Unity. All right, so before we jump into setting everything up, I just want to say that I'm using Unity version 2019.3.15, which is the latest version at the time of recording. And then if we go into the package manager, just go to Window Package Manager, you'll see that these are the preview packages I've enabled. The easiest way to get all the ECS stuff, of course, is to just install the hybrid renderer package, and that will give you all the entities and everything you need. So this is currently entities version 0.
Yeah, the CodeMonkey one. It effectively was just like, yeah, you don't need code to do what you're looking for.
0.11. As far as other packages that I'm using the new Unity physics package just so I can have this sphere kind of roll around in our world, and this is version 0.3.2. I've also included ProBuilder to just build out this simple little world, and then optionally, if you do want to use Cinemachine, you're going to go ahead and have to include the Cinemachine stuff as well. So anyways, here's the simple little scene that I created. You'll see that I have these 3 planes that I created just using simple ProBuilder planes. If we go over to see actually what's on them, you see that I just have the...
What it almost sounds like is that like I'll have to take a... I'll have an object that's attached to the vehicle. And then the vehicle will, when the vehicle moves, I'll probably move an object in outside of dots, and then that will allow me to have things work correctly. But I don't even know if that's going to be correct.
The standard mesh collider that I got from ProBuilder. If we go to physics body, I just set it to a motion type of static, because obviously these are just going to be static kind of ramps within our world. And then of course we have the convert to entity with a conversion mode of convert and destroy. So that will actually convert these into entities so they can interact in the ECS world. So if we zoom in a little here, you'll see that we actually have 2 spheres. I have one that's going to be our entity and one that's going to be our game object. This game object is basically just a transform and a mesh renderer at this point. And then on the entity, we have a physics shape, which is set to a shape type of sphere, of course. And then under the physics body, we've set this to a motion type of dynamic. And then lastly, we just have the convert to entity script set to a mode of convert and destroy. So overall, it's a pretty basic setup. If we go ahead and hit the play button, you'll kind of see what happens here. So you see the entity sphere just drops to the ground and it starts interacting with the entity ramps down here. And of course, our game object doesn't have any physics stuff on it, so it's just going to be staying in place right there. So basically what we're going to do here is on this game object, we're going to have a script that basically just has it point to this entity here, and it's going to mirror the transform of that every single frame. So we'll go ahead into our scripts folder and go ahead and create a new C# script, and I'll just go ahead and call this...
Holy shit, he's doing literally exactly what I thought he was going to do.
the follow entity script, and we'll go ahead and open this up in our IDE of choice. So at the top here, we're just going to go ahead and include a couple libraries. So we'll be using unity.entities, so we have access to the ECS stuff. We'll also have unity.mathematics because we're going to be using the float3 variable type. And then lastly, we'll include unity.transforms, so we can actually look at the translation component of the entity object that we're going to be following. Having a public class called follow entity inheriting from mono behavior, that is all just fine. So we're going to create a public entity called entity to follow. Of course, it's going to be a reference to the entity we want to follow. Next, we're going to have a public float3 called offset. This is an optional one. If you're using Cinemachine, you don't need to worry about this, but I'm including this to demonstrate how to use this using the traditional Unity camera. And then finally, we just need a private reference to the entity manager, and that's what we're actually going to be using to get the translation data from our entity. So next, we'll just go ahead and create an awake function. And this is where we're actually going to set the reference to our entity manager, and we do that by setting manager equal to world.default game object injection world, and then we can just get a reference to the entity manager. After the awake function, we're going to go ahead and create a late update function. If you're not familiar with late update, it's similar to update in that it runs every single frame, except late update runs at the end of every single frame. And we want this to run at the end of every frame so we can be sure that our entity is going to be in its final place that it's going to be before the frame is actually rendered. So when you're dealing with camera stuff, you typically want to include things within the late update function. So first thing that I like to do is just do a simple null check on the entity to follow, and so if entity to follow is equal to null, we'll just return out of the function. So that way we don't get any error messages or anything like that. So once we confirm that we do have a reference to an entity to follow, we're just going to go ahead and grab the translation component of that entity. Of course, the translation component is basically the ECS equivalent of the transform component. So once we have that translation value, we can just go ahead and set that translation value to the transform.position of this game object, and if we want, you can add in the offset. So we'll just go ahead and save the script and come back to Unity. So now on this sphere game object, we can go ahead and drag the follow entity script on here.
I missed late update when I messed with Godot. Or Godot. Is it Godot or Godot? I can never remember.
Of course, you'll see that here's where we can set the offset. Now you'll notice that we actually do not have a public field for our entity, even though we set that as a public field within our script. So the way to get around this is we need to create a custom authoring script, which we're going to be putting on the sphere entity, which is basically going to set the value of the entity in the game object that's going to be following it. So in the scripts folder, we'll just go ahead and create a new C# script. And I've just gone ahead and called this leader authoring. So here we have the leader authoring script, and we're going to go up here and we'll just include the unity.entities library along with the Unity engine library. And then so as a best practice, there are a couple attributes that I like to add to these authoring classes. So the first is requires entity conversion. So it's basically just going to give you a little warning if you do not have the convert to entity script on this game object. And the other attribute is this add component menu. And then here I've just defined that it's going to be in the custom authoring folder, and it's going to be called leader authoring. So if you save this and go back to Unity, we can now go on our sphere entity and go ahead and add a component. You'll see we now have this new folder called custom authoring, and under that we have the leader authoring. So go ahead and click that. You see that we now have the leader authoring script on here. So because it's a custom authoring script, we're still going to be inheriting from mono behavior. We're also going to be implementing an interface, which is the iConvert game object entity interface. Of course, I'm using Visual Studio and it's giving me a red line under it because we haven't implemented all the proper functions for the interface. So a nice little shortcut we can do is Alt Enter and then hit Enter again, and now it gives us this public void convert function here. Now this convert function is called when we're actually converting the game object into an entity using that convert to entity component. So first thing I'm going to do is create a public game object variable called follower object, and so this is basically just going to be a reference to the object that's following it. If you wanted to make this so like multiple objects follow it, of course you can make this a list of game objects. So you see here on the convert function we do have a couple variables that it gives us. So we of course have our entity. This is the only one that we're actually going to be caring about. We also do have the entity manager as well as a reference to the game object conversion system. So on the follow
This I convert to, yeah, so the I convert object to game entity doesn't exist anymore. I just want take a look at the I don't want you to send me an email with it. I just want the files. Like not the entire files. I just want the yeah, whatever.
follower object, we'll just do a simple get component call for the follow entity, and we'll just go ahead and set that into a variable called follow entity. Of course, we'll just do a little bit of error checking just to see if follow entity is equal to null. If it is, we'll just go ahead and set that follow entity variable equal to follower object.add.
So that's going to be a bit of a problem. With how old it is, it might actually be a problem. I think this one's pretty new, right?
Hello Day4Jess. In today's tutorial, we'll learn how to implement the camera so that it can follow player transform from within the ECS code. So let's dive in and see how it's done. First, let's add the Cinemachine package, as I want to use the camera to follow the player. Let's go to Window, Package Manager, and search for Cinemachine. Download the package. Here is an editor error, which you can ignore. So let's create a virtual camera. Right-click in Hierarchy, Cinemachine, Virtual Camera. Let's reset transform and change body to framing transposer so we get smooth to the camera movement. And reset X, Y, Z damping. Set camera distance to say 30. Set aim to do nothing. Also select tag main camera for virtual camera. Remove this tag from main camera object. As you can see, the Cinemachine brain component responsible for managing the main camera has appeared. We'll leave it unchanged. So time for coding. Okay, let's remove the destroy entity from player movement system. We don't need it anymore. Let's create a new partial class, player camera system, that inherits from system base, as we will be performing manage operations. And of course, implement the onCreate, onUpdate, and onDestroy methods. Then add attribute, update in group, type of simulation system group. Before we get any further, to improve readability, let's refactor the name player animation component data to player manage component data. It's much clearer. Also, let's add a game object and transform to the component and pass them at the time of creation, i.e. in the player visualization system. We can remove the ECB here along with the method and use state.entityManager.addComponentObject. Let's correct the naming. Now we can delete the game object directly in the player animation cleanup system. Alright, let's go back to the player camera system class. First of all, let's add player entity query, from which we'll get the player manage component data component. Let's not forget to add required for update. In the onUpdate method, we want to set the follow of our virtual camera, so we will use the main camera tag. So let's create virtual camera variable and then write if virtual camera is not null, return. Now we need to find camera object, so virtual camera equals game object.find game object with tag main camera dot get component scene machine virtual camera. Although this is not a very efficient method, it's enough if we only need to do it once. Next, we'll retrieve the player manage component data from entity query. And at the very end, all we need to do is set virtual camera.follow to player manage component data.transform. Let's go back to Unity and test this feature. Wait for the recompile process to finish. Press play. And as you can see, virtual camera is correctly following the player. I warmly invite you to support us on the Patreon, where I share manage component data from entity query.
That's actually pretty simple. I like this. I think we're going to steal his. Okay, so let's go back a bit here. Just want to see exactly what we're doing here. So we're just creating a new system base. And then we do the query builder, player manage component data. And then we just grab the virtual cinema camera, find with tag main camera. Oh, yeah, that's super easy. Is it perfect? Absolutely not. Will we probably be changing things down the road? Absolutely. Do I need to do that right this moment? Absolutely not. So we need a Cinemachine camera. And then we want to main camera. And then we untagged there.
First, let's add the scene. Download the package in hierarchy, scene machine, virtual camera. Which you can ignore. So let's create a virtual camera. Right click in hierarchy, scene machine, virtual.
Wait. What? We need a virtual camera? I don't see virtual camera. I assume that this is a virtual camera.
Virtual camera. Let's reset transfer and change body to framing transposer so we get smooth.
Okay. Yeah, it kind of looks that way, right? Is the Cine camera in the exact same spot? Oh, it is. That's why. There we go. Beautiful.
Move to the camera movement and rest.
He has settings that I don't. I don't know if this is actually the one I want. I think this is probably the one that I want here, and then we can just delete this one. And then we do this, untagged, we do main camera, and then we do there. What we'll do is we'll take this, copy, Paste. Key happy. Oops. That's weird, right? It works.
Set X, Y, Z dumping.
Okay, so he's got body. Tracking target. I actually wonder if this is going to work. I don't think it is, but no, it won't work.
Set camera distance to say 30. Set aim to do nothing. Also select tag main camera for visual camera. Remove this tag from main camera object. As you can see, the Cinemachine Brain component responsible for managing the main camera has appeared. We'll leave it unchanged. So time for coding. Virtual camera. Let's reset transfer and change body to framing transposer so we get smooth 2D camera movement. And reset X, Y, Z dumping.
One sec. Maybe I did this wrong still. Give me a second here. Okay. Oh, this has a tracking, right?
Virtual camera. Right-click in hierarchy. Cinemachine. Virtual camera. Let's reset transfer and change body to framing transposer so we get smooth 2D camera movement. And reset.
Yeah, we don't have a body. We're missing a lot here. But I think we should be fine because this we should be okay.
Set X, Y, Z dumping. Set camera distance to say 30. Set aim to do nothing. Also select tag main camera for visual camera. Remove this tag from main camera object. As you can see, the Cinemachine Brain component responsible for managing the main camera has appeared. We'll leave it unchanged. So time for coding. Okay, let's remove the destroy entity from player movement system. We don't need it anymore. Let's create a new partial class player camera system that inherits from system base, as we will be performing manage operations. And of course, implement the onCreate, onUpdate, and onDestroy methods.
Yeah, so we need an onCreate.
Then add attribute, update in group, type of simulation system group.
vehicle wheel. I did a update last. There we go.
Before we get any further, to improve readability, let's refactor the name player animation component data to player manage component data. It's much clearer. Also, let's add a game object and transform to the component and pass them at the time of creation. It is in the. Also, let's add a game object and.
Okay, so here we need a public struct player managed player cam component data. Actually, I guess that would make sense because it's a if it's managed, it needs to be a class, not a struct. Follow target. I think that's all we need.
Transform to the component and pass them at the time of creation. It is in the player visualization system. You can remove the ECB here.
We need a transform as well, sorry. And then on update, oh, give me a second here.
Them at the time of creation. It is in the player visualization system. You can remove the ECB.
We need to get the player version. We need to get the God damn it. Sorry. On update, we need to get this game object, right? So this would be this also requires game object. Public game object, follow target, and
here along with the method of creation. It is and pass them at the time of factor the name player animation component data to player manage component data. It's much clearer. Also, let's add a game object and transform to the component and pass them at the time of creation. It is in the player visualization system. You can remove the ECB here along with the method and use state.entityManager.addComponent object. Let's go.
Player animation entity. I don't care about that. We're not doing animations. I think this is all we need, but we don't need that. We just need this. And then we just need to get the player target. Player, and let's see. Where are we stashing this stuff? You know what? I might actually just follow that old one.
Set and our velocity.
Hello everybody and welcome to today's video where I'm going to be showing you how to there. So basically what we're going to do here is on this game object, we're going to have a script that basically just has it point to this entity here, and it's going to mirror the transform of that every single frame. So E of choice. So at the top here, we're just going to go ahead and include a couple libraries. So we'll be using unity.entity transforms. So we're going to create a public entity transform.
Okay, so we need a mono behavior still. add new script mono behavior, and this will be follow. Follow player. Follow player entity controller. And then we have, I think we're doing stuff on the start. And then we need void late update.
We'll also have unity.mathematics because we're going to be using the float3 variable type. And then lastly, we'll include unity.transforms so we can actually look at the translation component of the entity object that we're going to be following. Having a public class called follow entity inheriting from mono behavior, that is all just fine. So we're going to create a public entity called entity to follow. Of course, it's going to be a reference to the entity we want to follow.
That's fine. Okay, so public entity, follow entity.
Next, we're going to have a public float3 called offset. This is an optional one. If you're using Sandmachine, you don't need to worry about this, but I'm including this to demonstrate how to use this using the traditional Unity camera. And then finally, we just need a private reference to the entity manager, and that's what we're actually going to be using to get the translation data from our entity. So next, we'll just go ahead and create an awake function.
Okay.
And this is where we're actually going to set the reference to our entity manager, and we do that by setting manager equal to world.default.
We need an awake.
Game object injection world, and then we can just get a reference to the entity manager. After the awake function, we're going to go ahead and create
Game object. I think this one's better, right? So we have our game object. Wait, we don't. No, this is not right. Yeah. This would be the follow entity, but that's not right either. There we go.
a late update function. If you're not familiar with late update, it's similar to update in that it runs every single frame, except late update runs at the end of every single frame. And we want this to run at the end of every frame so we can be sure that our entity is going to be in its final place that it's going to be before the frame is actually rendered. So when you're dealing with camera stuff, you typically want to include things within the late update function. So first thing that I like to do is just do a simple null check on the entity to follow, and so if entity to follow is equal to null, we'll just return out of the function. So that way we don't get any error messages or anything like that. So once we confirm that we do have a reference to an entity to follow, we're just going to go ahead and grab the translation component of that entity. Of course, the translation component is basically
if followed entity is null, we just want to return. I feel like we should do a debug here though, but whatever. Translation. OS. Using unity.transforms. Yeah. Manager, entity manager dot get component data translation entity, sorry, follow entity. Interesting. This doesn't work anymore. I think this is the world transform, right? I feel like this is it.
So just go ahead and save the script and come back to Unity. So now on this sphere game object, we can go ahead and drag the follow entity script on here. Of course, you'll see that here's where we can set the offset. Now you notice that we
Now all we need, we're gonna try this, but
we actually do not have a public field for our entity, even though we set that as a public field within our script. So the way to get around this is we need to create a custom authoring script, which we're going to be putting on the sphere entity, which is basically going to set the value of the entity in the game object that's going to be following it. So in the scripts folder, we're just go ahead and create a new C# script. I've just gone ahead and called this leader authoring. So here we have the leader authoring script, and we're gonna go up here and we'll just include the unity.entities library along with the Unity engine library. And then so as a best practice, there are a couple attributes that I like to add to these authoring classes. So the first is requires entity conversion. So it's basically just gonna give you a little warning if you do not have the convert to entity script on this game object. And the other attribute is this add component menu. And then here I've just defined that it's going to be in the custom authoring folder, and it's gonna be called leader authoring. So if you save this and go back to Unity, we can now go on our sphere entity and go ahead and add a component. You'll see we now have this new folder called custom authoring, and under that we have the leader authoring. So we go ahead and click that. You see that we now have the leader authoring script on here.
I don't know which one of these I like more. I feel like this person's more up to date, and that could be the difference. There's just some confusion here.
Now we can delete the game object directly in the player animation cleanup system. Alright, let's go back to the player camera system class. First of all, let's add player entity query, from which we'll get the player manage component data component. Let's not forget to add require for update. In the onUpdate method, we want to set the follow of our virtual camera, so we will use the main camera tag. So let's
where were we here?
And of course, implement the onCreate simulation system group player manage at the time of creation. It is in the player visualization system. We can remove the ECB here along with the and pass them at the time of creation. It is in the player visualization system. We can remove the ECB.
Player visualization component data. The get singleton here, this doesn't make sense to me. I wish this guy wasn't doing it in a very large system here. Unity dots cinema follow camera. Oh, here we go. Spawn game object and link it with your player entity using companion link. Create prefab with simple mono behavior to find CM camera. Find CM camera. Add game object prefab component data to store game object reference in your player entity. Spawn game object prefab and link it with your player entity using position link. Start is called before the first frame update. System to spawn and link game object to your player entity. With all game object prefab. .build. Required for update query. Undestroyed, doesn't need anything. Ref system state. Get singleton, begin simulation, entity command buffer system singleton. create command buffer for each game object that initiate go prefab dot prefab. Where's go prefab? This is, oh, this is here. Yeah, okay. New game object prefab using authoring.prefab, and there's our game object prefab component game. From what I gathered, component comparison link is not meant for public use and is function and its functionality is limited to certain. I think what we're looking for, and I think I'm going to try this first before I go any further here. All I want to do is get the entity here, right? So this will be find or get entity. Entity transform. Update. So if I have my entity manager dot get component data, I feel like it is get component data, and then this would be local to world, and then we would pass in the followed entity, and this would be local to world. And then we're going to do a debug.log. Local to world. Okay, there. And then we go to our controllers. Controllers. We attach that to here. Wait, what? Shouldn't we be able to see this? I feel like I should be able to see it, right? Give me a second here. Interesting.
Here. behavior. So because it's a custom authoring script, we're still going to be inheriting from MonoBehavior. We're also going to be implementing an interface, which is the iConvertGameObjectEntity interface. Of course, I'm using Visual Studio and it's giving me a red line under it because we haven't implemented all the proper functions for the interface. So a nice little shortcut we can do is Alt-Enter and then hit Enter again, and now gives us this public void convert function here. Now this convert function is called when we're actually converting the game object into an entity using that convert to entity component. So the first thing I'm going to do is create a public game object variable called follower object. And so this is basically just going to be a reference to the object that's following it. If you wanted to make this so like multiple objects follow it, of course you can make this a list of game objects.
Because I don't think, oh no, because I can do that. One sec. So if I go to Cinema Camera and then I do this, there's that, right? And then I have my game object here. If I go to player camera system here, we come over to here, then we go to my authoring. Right, I need the component data out in the in an authoring script. Here we do dots and authoring mono behavior, and this is player camera system authoring. Player camera system authoring. There. Then we go to the camera system here and come in, and we're just going to paste this in here. And then we're going to go to player camera system. Then we're going to do player authoring. And just do this. And then this would be can get entity be weird? No, we want entity reference authoring. I think this is the one that we want. Then we add the player camera system. And then this is going to be a new player camera system. And then this would be game object equals. Yeah, this is kind of the problem here. Game object reference. Oops. Object reference, maybe? Game object reference. Maybe. System query builder with all.
We'll retrieve the player managed component data from entity query. And at the very end, all we need to do is set virtual camera to retrieve the player managed component data from entity query. And at the very end, all we
Unity dots. Cached access to a set of component data. Drop handle update. It's not quite what I'm looking for. How old are you? 9 months? Okay.
Hello everyone. Today we'll see how we can integrate Cinemachine Controller to do some more advanced stuff that will always have a line of machine control this little character. How we can reproduce. There should also be the physics that are two walls. Not I'm snapping the camera to the wall to be able to see it. And here I did controller with the character controller. We can just set wall. Still using a series, and I'm reusing the game object companion authoring that was a part of that tutorial video. And I'm spawning a free look camera. So it's the Cinemachine camera. The way so setting another component, which is the tracking target. And for the tracking target, I'm using the camera target that is below the third person controller. And that allows me to do the link with the free look camera. And with this tracking target, I actually have a system. So it's baking the
Oh, okay, yeah. Okay, So this is what we're doing here for the baker. Get entity. This is get entity. Oops. Game object here would be get entity. No, it's not an entity that I want though.
Camera target game object. So I'm getting the actual entity. So the entity that will be here in this place in the hierarchy. And I'm storing it in a component. And with that component, I'm actually assigning the Cinemachine camera tracking target to the
machine. Okay, wait. And then this is the eye system.
The transform component, so the companion game object of that entity, because I've added same thing here on the camera target with a tracking target, and that is just an empty prefab because I need a prefab to instantiate at runtime. If you want more details about how this companion game object works, you can look at my other video in the Dots masterclass. I will put a link in the description below. But that's how I'm making the link between my Cinemachine setup and the entity I need to follow. So if I enter play mode.
Wait, he's putting the Cinemachine camera inside of. So he's putting this inside of here. Interesting. And then we're doing a get entity. Oh wait, no, that was it. Oh, okay, yeah. I see how this is working now. So then we would this is an entity. Right? And then we would do authoring. Actually, I guess this needs none, right? Because it's just a link to it. We don't actually care. This goes somewhere else. Oh. there. There's a camera. So if we do this, and we do go here. There we go. And then I do the player cinema camera system, right? And then on update, right, we do the this is the one we want here on update. I almost say that we can probably do this with a let's try an eye system first. I don't think that this is going to work, but eye system. There we go. And this is public void on update. Ref system state. And when you do that, then here we do equals system API dot get singleton. Really all we want is to actually get the camera itself. Can we use a world? Right? Right, this is not correct. There's this, and then we have our, do we have the follow? I wonder if we can get this as an as a reference. I don't think this is going to work. But we might have an idea for how to do it if we look at the vehicle wheel stuff. I'll be right back. It's about 2 o'clock. I'm gonna take I'm gonna do lunch real quick here. So I'm gonna run a bunch of ads while we. Oh fuck! It won't let me run ads right now. I'll be back in a couple. I'm just gonna go get my food. It's chilly. Got the microwave going. We're gonna have food soon, and then I'll be able to munch and get back to this. Right now, the trick that we want to do is communicate out from a out from the entity to a game object. Unity dots send information to a game object. Here we go. World dot. Okay, here. Mono behavior, getting or setting an entity component data. Create entity query. So this is in mono behavior. System no burst compatible. Interact with interacting with mono stuff and getting / setting transforms. If you need to access mono from ECS, you can use a managed component and have a reference to a game object. Example below. So as long as it's a managed object, we should be able to be fine then. be right back. Okay. If we go to the authoring and we turn this into a class, this can now be a game object. So we can't add components for a, huh. Baker. Here we go, the baker. New controller data. Character controller data. There's the data, but oh yeah, you know what? Add component object. Right. Right. Yeah. Okay. I'm on the right. Okay, I figured it out. Yeah, so we don't pass in the entity, I don't think. No, we do. And then on update, I think we can do. I think we can do the pedestrian move. Ooh, excuse me. I think we don't want this. We want the system base. Yeah. This is reading data in. We want to take data out. Cinemachine? This is effectively all we need. No, that's not what we want. Local to world. Here's my for loop thing. This doesn't have one. Cool. Beautiful. 10 out of 10. I think it's Query Builder, actually. System API Query Builder. Controller. Okay, so this is yeah. So here we do build dot builder. Where is it? How does this work? Dot builder dot I don't think it's this. With it's like system API dot be right back. Hmm. think I think it's just this. Right? Then we delete these two. Then we do with tag or with present. Specifies all read-only component types that must be present, whether enabled or disabled. Yeah. With present player tag. Then this gives us a query back, right? With only the information that we care about. And then we should be able to, from here, we have the cinema camera, right? But we want a get this. No, we want the target. There's that, and then we also want this player camera system. Hmm. Do. What's the error here? Must be a non-nullable value in order. look up the value of a component of an entity. Okay, so this would be protected, override, void, and this is public. This isn't a cinema camera that I want. This is a game object. Um, private entity. Auto target game object. Follow target entity. Here we go. So then on update, we have the singleton here, and we get local to world transform from the target entity. And then here we do system API dot get component local and then we give the follow target entity. And this gives us a local to world. And then what we can do the follow target entity. Wait, what was this? No, dot transform. I just realized I don't need this at all. I don't think I'm actually using this. That work? What? Project settings, tags, and layer. Oh, it's there. That's why. Okay, I was just misunderstanding it. Okay. I think this actually just covers it, doesn't it? It totally doesn't work. I think what we need to do here is we need to do this, and if is if not follow entity? Yeah, because entity is it nullable? It's a struct. We'll do this. This should work, I think, but yeah, you never know. This is player camera system. It's not following it. Of course. This game object only exists at runtime. What do you mean it only what do you mean it only exists at runtime? Yeah, like what? It's oh, wait. Is this actually a thing? Yeah, no, that's totally updating that. So, dope. It's updating. It's updating. It's totally updating. Look at that. It works. I don't even need this. Remove component. All right, so it is there, but the camera won't follow it. Look at that, it works. I like how it works with that with the control. Actually, no, this is not rotating correctly. Yeah, it doesn't rotate the camera. I wonder. No, you can't move that. Can I rotate it? No. Follow offset, we can do this. Oh, that's perfect. I think this will actually do the thing. So then we turn. It's following the turn. Yeah. Oh, it's good. It's good. It's good. the the jump is not great, but watch it. Oh, the jump is bad. The jump is bad. The jump is bad. Because the camera allows it to like catch up and go whatever. It doesn't go behind. But this is actually not a bad little camera, all things considering. Look at the follow. The follow actually is pretty good. Look at that. I am very happy with where we are right now. Oh, baby. Yeah, yeah. Look at that. It's freaking amazing. Super amazing. And I really didn't follow anybody's tutorial for that. Like maybe a little bit, but not really. It's fucking great. 10 out of 10. Absolutely love it. What was I going to do? Right. I need to buy that still. AI AI books. Game AI books. Game AI books. This is the one. The third volume of the A behavior tree. Let's see, an introduction to utility theory. The different types of game AI. Is it AI? I think it's the utility system that I want. Because it's not behavior trees. In video game AI, utility system or utility AI is a simple but effective way to model behaviors for non-player characters using numbers, formulas, and scores to rate the benefit of possible actions. One can assign utilities to each action. What's the new one from Unreal? Unreal AI. State tree, that's the one. Anyways. Let's get started. We're going to be effectively doing this for like the next month. Game AI is going to be a huge part of this. By the way, I'm still torn between what I should be using for my next game. Because I'm going to be starting that game with my friend later today. And I'm not sure if I should use Unity or Unreal. He has no preferences. So I've got to figure that one out. And based off of the character that we're going, like the copy image link. Based off of the character style that we're going to be using, I don't know. I don't think it would be necessarily worth it to, like, I don't think it matters what engine we use, right? Because I think our poly count's going to be low enough that it doesn't matter. This particular one is just poly painted, but like he can re-topo it down to be better. And it's just a matter of figuring out like the UI and stuff like that. And I was kind of leaning towards Unreal because it might actually just be faster for me to do it in Unreal. But it's kind of hard to say. Because like the idea is like the UI. The UI is going to be the hard part. I think the UI is going to be the hard part. And then I just need to find a working title for the game. Okay, let's blow this up. Maybe out just a little bit. Let's see, introduction. Game AI should be out about one thing and one thing only: establishing the developer. Sorry, one thing only: enabling the developer to create a complete experience for the player. Every technique we use, every trick we play, every algorithm we encode, all should be in support of that single goal. Wikipedia gives the following as a definition for artificial intelligence or AI: the study and design of intelligent agents, where an intelligent agent is a system that perceives its environment and takes actions that maximize its chances of success. We can skip some of this. Film animators often describe the artificial life which they create as the illusion of life. Creating an experience. Every game is different, and the AI needs for games vary widely. With that said, the goals for a game's AI generally have much more in common with Disney's view of artificial life than with the classic academic AI like cartoons, games. Creating an experience. It is often said that rather than maximizing the chance of success, The goal of an AI is to maximize the player's fun. This is true. The goal of the game is to maximize fun. This certainly can be the goal of AI, but it probably isn't the best definition. For one thing, much like the term AI, fun is a word that is notoriously hard to define. This is true. When I say it is to maximize the player's fun, it is like when I play the game, am I having as much fun as possible? Is the AI just diminishing my fun? Right? And if the AI is not diminishing my fun, then we're in a good spot. If the AI is contributing to more fun, then like introducing a challenge that I need to overcome, or doing something that makes the game more fun, then that's fun, right? That's how we define it. That's how I'm defining it. For another, not all games are about fun. It's not true. All games are about fun. It's just subjective fun. Fun is subjective. It's not notoriously hard to define. It is subjective. It is 100% a subjective thing. Because what I find fun isn't necessarily what you're going to find fun, right? We might share fun as in like, we might both agree that one game has fun aspects, but we might like those aspects differently and for different reasons, right? But no, all games are about having fun. It's just that fun can be a frustration and the overcoming of it, right? Leading to a feeling of joy, right? Telling some games are about telling a story or about the really cool characters that they contain. Yeah, but that's still fun, right? It's fun to watch or fun to read or fun to participate. Others are about creating a sense of excitement, adventure, suspense, or even fear. Yeah, but some people find that fun. Him or her feel like the man, about giving the player a sense of empowerment. The one thing that is universally true is that games are about creating a particular experience for the player, whatever that experience may be. The purpose of game AI and every other part of a game, for that matter, is to support that experience as concisely. As a consequence, the techniques that are appropriate for use are simply those that best bring about the desired experience, nothing more, nothing less. This is true. Suspension of disbelief. Players are willing to participate in the experience that we are creating for them. They want to buy in to our illusion and so willingly suspend the natural disbelief they would normally feel for such obvious artificial characters and events. With that said, it is our responsibility to provide an illusion that is sufficiently compelling to enable them to do this. That is, to maintain the player's suspension of disbelief. We succeed any time that the user thinks about and responds to the AI as if it were real, even if the underlying algorithm is actually quite simple. Ours is actually going to be quite simple. We fail anytime that some action or interaction on that part of the AI reminds the user that the AI is only a machine program, not real. I don't know. I never mistake a AI for a real person, right? In a game, it's usually pretty well defined. The only time that you'll mistake them is like when they're purposely there to deceive you and act like a really bad player on your team in a multiplayer game. And even then, people aren't super fooled by that. And usually the only time that you're willing to suspend that disbelief is if you're in a multiplayer game and you're just stomping all over them. It's like, I am the man, and they're not being super blatantly obvious. Like their name isn't 123, I'm the biggest bot ever. An AI psychologist developed by Joseph Weizenbaum in 1964, Wikipedia do, it exemplifies both how easy it can be to capture the player's belief with a simple algorithm and how quickly you can lose that belief when the algorithm misbehaves. Because they are willing to participate in the experience and because of the way the human mind works, players are actually quite forgiving as long as the AI produces behaviors that is basically reasonable. The player's mind will come up with explanations for the AI's decision that are often quite complex, much more complex than what is really going on inside of the AI, but also fundamentally compelling and believable. In fact, to some extent, it can be a mistake to build an AI that thinks too hard. Not only can it be a waste of precious development hours to over-engineer your AI, but it can also result in a character that will perform actions that, while sensible to the AI, don't match the player's mental model for what the AI is doing. In other words, the actions make sense if you know what the AI is thinking, but of course the player can't know that. As a result, those careful chosen decisions end up looking random or just plain wrong. The one thing that we absolutely must avoid at all costs is artificial stupidity. That is, selecting an action that looks obviously wrong or just doesn't make any sense. Common examples are things like walking into walls, getting stuck in the geometry, or ignoring a player that is shooting at an enemy, shooting at you. Even some behaviors that actual humans would display should be avoided because those behaviors appear inhuman when performed by an AI-controlled character. For example, humans quite frequently change their minds, but when an AI does so, it often gives the impression of a faulty algorithm rather than a re-evaluation of the situation. One solution to the problem of artificial stupidity is simply to make the AI better, but player expectation can be so diverse that it is hard to meet all of them all the time. As a result, a variety of approaches have been used in some games. Zombie games are a good example of this. The characters are deliberately made to be a little bit stupid or wonky so that their strangeness will be more acceptable. In others, the characters use short spoken lines, sometimes called barks, to clue the player into what's going on. For example, they might yell grenade or I'm hit. These aren't really used to communicate with other AI characters. We do that to pass messages in the code. We do that by passing messages in the code, but rather to explain their actions to the player, sometimes such as The Sims or Zoo Tycoon. go so far to put icons over the character's head, signaling what's going on internally. Creatures, a game still known 15 years after its release for its groundbreaking AI. Really? Creatures? Oh, I think I've heard of this. Groundbreaking AI even used a puzzle icon when the creature changed its mind to show that the resulting change in behavior was deliberate. Reactivity, non-determinism, and ethereal control. Much discussion has been given to the various architectures and which is the best for game AI. Indeed, an entire section of this book is dedicated to that purpose. The first throughout that one might draw from academic AI to build an AI with a heuristic definition of the desired experience, and then use machine learning to optimize for that experience. There are several problems with this approach, but the most obvious is that the experience is typically something defined by the game designer, who may or may not be a programmer. Using squishy human language and language terms, how do you write a heuristic function to maximize fun or excitement or cool attitude? This isn't to say that heuristic functions are useless. In fact, utility-based approaches to AI are one of the most common approaches, particularly for games with more complex decision making, i.e., strange strategy games and simulation games like The Sims or Zucchine Tune. It is critical, however, to retain ethereal control, which is to say, to ensure that the AI's author can tune and tweak the AI so as to ensure that the desired experience is achieved. If we relinquish that control to a machine learning algorithm, it becomes much more difficult to ensure that we get the results we want. There is a competing need, however, which is that we want our characters to be reactive. That is, able to sense the environment and select actions that are appropriate to the subtle moment by to moment nuances of the in-game situation. Relative, reactive, and ethereal control are not mutually exclusive, but you can build situations when making its decisions. It's still the sub Fox. Yeah, I'm getting tongue tied, but I have to read this. What? You just came to give me that? Jeez, so rude. Let's see if I can see the message. Of course, I don't get to see the message. I do not know the meaning of that specific character thing that you sent. Because you control the way that it evaluates the situation, making its decision. It's still possible. Provides ethereal controlling a reactive AI is more complex, however, because you as the developer have to think through how your changes will alter the AI decision making rather than simply change what the character does directly. There isn't a single right answer here. Some games, such as strategy games or games like The Sims, require more reactivity, while other games, such as World of Warcraft, make a deliberate decision to have more heavily scripted AI that delivers a carefully crafted but highly predictable experience to the player. Neither is wrong. We're going probably for a rule-based AI. I think that's what we're going for. Or maybe a I don't know. It's definitely not this. I don't think planning is going to be really there. There's going to be probably a little bit of planning. But I think we can skip a lot of this. What? Oh, this is general wisdom. Advanced randomness techniques. Critical thinking. AI often invokes mechanism higher. Don't neglect the look at that math. Hey, look. All the things that I wanted here. Introduction. Here we go. Writing artificial intelligence systems for games has become increasingly complicated as console gamers demand more and more from their purchases. At the same time, smaller games for mobile platforms have bust onto the scenes, making it important for an AI programmer to know how to get the best behavior out of a short frame time. Oh, yeah. Frame time is in like how long it takes to render a single frame. So how much compute can you actually throw at something? Even on complicated games running on powerful machines, NPCs can range from simple animals the player might run past or hunt to full-fledged companion characters that need to stand up to hours of player interactions. While each of these example AIs may follow the sense, think, act cycle. The think part of the cycle is ill-defined. There are a variety of algorithms to choose from, and each is appropriate for different uses. what might be the best choice to implement a human character on the latest console might not be suitable for creating an advanced adversarial player for a web-based board game. This article will present some of the most popular and proven decision-making algorithms in the industry, providing an overview for those choices and showing when each might be the best solution to use. While it is not a comprehensive resource, hopefully it will prove a good introduction to the variety of algorithmic choices available to the AI programmer. I think we want something like a finite state machine, to be honest. Like, effectively what we need is we have an AI, right? We have a street. Let's change colors. We'll say the green part. We have a street, then we have a road, right? And the street will end. Oops. It bends like this, right? Yeah, and then we'll have green, and this will be, I'll put this as dotted green. No, this should be yellow. No, orange. Right? And then this will have like maybe a red light, a yellow light, or a green light. And then this AI would make up its mind if it wants to go this way, or this way. That's effectively all the AI we need. Right? As long as we have that, we're good. So it's hard to say which one of these is going to be best. And I'm kind of leaning towards maybe a finite state machine. Finite state machines are the most common behavioral modeling algorithm used in game AI programming today. Finite state machines are conceptually simple and quick to code, resulting in a powerful and flexible AI structure with little overhead. They are intuitive and easy to visualize, which facilitates communication with less technical team members. Every game AI programmer should be comfortable working with finite state machines and be aware of their strengths and weaknesses. And a finite state machine breaks down an NPC's overall AI into smaller discrete pieces known as states. Each state represents a special behavior or internal configuration, and only one state is considered active at a time. States are connected by transitions. Directed links were responsible for switching to a new active state whenever certain conditions are met. One compelling feature of finite state machines is that they are easy to sketch out and visualize. A rounded box represents each state, and an arrow connecting two boxes signifies a transition between states. The labels on the transition arrow are the conditions necessary for that transition to fire. The solid circle indicates an initial state, the state to be entered when the finite state machine is first run. As an example, suppose we are designing an FSM for an NPC to guard a castle, as in figure 4.1. Our guard NPC starts out in a patrol state where he follows his route and keeps an eye on his part of the castle. If he hears a noise, then he leaves patrol and moves to investigate the noise for a bit before returning to patrol. Yeah. If at any point he sees an enemy, he will move into attack. He will move into attack to confront the threat. While attacking, if his health drops too low, he'll flee to hopefully live another day. If he defeats the enemy, he'll return to patrol. While there are many possible finite state machine implementations, it is helpful to look at an example implementation of the algorithm first. Is the FSM state class, which each of our concrete states, attack, patrol, etc., will extend. See enemy dead, search failed, hear noise, investigate, health low, flee. Hey, look, they pretty much blocked out everything that we cared about. Now the only question about this is like, when we do this, right? Because I think this is the way that we're going to go. State, enter, update, exit. List finite state transitions. Each finite state machine has the opportunity to execute logic at 3 different times. When the state is entered, when it is exited, and on each tick when the state is active, and no transitions are firing. Each state is also responsible for sorting a list of finite state machine transitions. Which represent all potential transitions out of the state. FSM transition. Virtual bool is valid. Get next state on transition. Each transition in our graph extends from FSM transition. The isValid function evaluates to true when this transition's conditions are met. And get next state returns which state to transition to when valid. The onTransition function is an opportunity to execute any necessary behavioral logic when the transition fires, similar to onEnter. The FSM state finally the finite state machine. Enter in FSM state. Yeah. Finally, the finite state machine class. We're not going to be doing something like this. We'll probably have to do this using a slightly different system because we can't attach methods or functions to how these work. So we effectively have to work around this. And what I'm thinking is that we'll do bitwise stuff. The finite state machine class contains a list of all states in our FSM, as well as the initial state and the current active state. It also contains the central update function, which is called each tick and is responsible for running our behavioral algorithm as follows. You know what? I think I know how I'm going to do this now. The only thing we need to do now is work out pathfinding. That didn't take long. I'll be right back. Okay, so here's what I'm thinking. Where did I put my... Both too cold and warm in here at the same time. So, one sec. Unity dots query. This might be what we're looking
Entity
for.
queries are an essential part of Unity's entity component system, and if you've used Unity ECS, then you've definitely used entity queries. But as I was doing research for this topic, I don't know if I really understood how deep entity queries go. So in today's video, we're going to be talking all about entity queries. We're going to be giving you kind of a general overview if you're not super familiar with what they can do yet. And then we're going to be going a little bit more into depth on some of the different types of entity queries and some of the cool things that you can do with them. But if you do find today's video helpful, I would really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots.
Just so you know, effectively all ECS is a giant state machine.
More videos about Unity's entity component system and their data-oriented technology stack. Of course, if you have any questions for me or suggestions for future videos, feel free to leave those down in the comment section below. We're doing this over on Discord over at tmg.dev/discord. So let's start at the top. What exactly are entity queries? So to put succinctly, it's basically a way to get a view of data in Unity ECS. Basically, the way that it works is when we define one of these entity queries, we say that, for example, we want all the entities that have this specific component or maybe this specific set of components. And then from that, we basically get this entity query, and then we can use that entity query to actually get the individual entities that have those data components. And so there are a number of things that we can actually do with these entity queries. So the most common one is going to be we're actually going to be able to run a job with that entity query. So basically, we have this set of entities now, and now we can kind of do something. We can iterate across all these entities and perform some data transformation. So these entities do things and things happen in our game project. Another thing that we can do is with our query, we can get a native array of those entities if we just want to have easy access to that native array of entities. We can kind of query for them, and then we can have that array of entities if we need to maybe iterate through them later or kind of like reference individual entities. We now have that array of entities based off of our entity query, and we can also get native arrays for the data components in our entity queries. So basically what this means is, let's say we have an entity query that says, give me everything with a translation component. Well, we can actually export that to a native array of translation components, and then we have this array of translation components that we can again iterate through or reference in the future. And one final thing that you can do with these entity queries is control whether or not a system is updating. In the video that I did on Unity singletons, I showed you how we can only update a method when that singleton is present. We can do basically the same thing by passing in an entity query into the require for update method, and that basically means that as long as we have entities that match that query, then the system is going to be updated. If there are no entities that match that query, that system will not be updated. Now let's talk a little bit about the different types of entity queries. So the main one, the one that we're going to be using the most often, and the one that is recommended to be used, is the entities.forEach. Now this is probably the first one that you learn because it's pretty much the easiest to use, and it allows us to do some simple as well as some decently complex things. So basically the way this works is we kind of define the components that we want inside our forEach function. So let me demonstrate this to you using this little sample project that you see playing behind me, where we basically have some kind of soldiers marching in a parade. And all the project files and code features in this video are available in the links in the description below. So here's the system, and inside the onUpdate function, we're defining our entities.forEach lambda function. And then inside here, this is where we're actually going to define our entity query. So first thing is this entity here. We'll just ignore this. We'll come back to this in just a moment. But this is actually the portion of the code where we're actually defining what data we want to query for. So in this case, we're going to be querying for any entity with a translation component as well as a soldier move data component. Now, there's a couple things to note here. The first is this: you'll see this keyword defined before each of these components. So the ref keyword means that we can read and write to this component, and the in keyword means that we can only read from this component. And it's very important that we define all the ones with the ref keyword, that is the read and write ones, before all the ones with the in keyword. And it's also very important that when we define our entity queries, that we specify these as read only if we only need read only access to them, because for one, it's much more efficient to have read only access to components, and number two, it can also cause some issues if we have write access to components that we don't exactly need write access to. And then you'll see after the component, we actually define a name for the variable. So for the translation one, I've just called it position, and then the soldier move data, I've also called soldier move data. And that's how we can actually access these as variables inside the entities.forEach function. Now, there are also a number of special named parameters that we can pass into the forEach function. I'm not going to go too into detail on these because they don't necessarily have to deal with entity queries, but basically there's three of them that we can use. The first one is entity, and we can call the variable anything that we want. I typically just use e or the word entity. The next one is an int, and it must be called entity in query index, and this refers to a unique identifier for each entity in our query, and this is very useful when we're integrating with entity command buffers. And then the final special parameter is an int native thread index, and this also must be called specifically native thread index, and this gives us the ID for the thread executing the function. It's most likely just going to be used for debugging purposes. And then one final thing to note about these parameters going inside the entities.forEach function is by default we can only have up to 8 of these. However, if we want to have more, we can actually use custom delegates to create our own. I'm not going to go over that in this video because that might be a dedicated video on its own. And so that just gives us this very basic behavior where we just go ahead and move all these soldiers forward in the parade, like you see playing on the screen here. And you see even in the far back where we have these black colored soldiers, they're still all just moving forward, even though the components on these differ from all the green soldiers. The ones in the back do still meet the requirements of having a translation component as well as the soldier move data component. Now, this is kind of only the beginnings of what we can do with these entities.forEach functions. So there's actually like a number of with modifiers that we can use, and I like to separate these out onto different lines here. So we can just go ahead and create another line, and so we can say with, and you'll see there's like a number of ones that we can use. So we can do a with all, a with any, a with none. There's also with change filter and with shared components, as well as with entity query options. Now I went over a couple of these in the video that I made on tags, using tags in Unity's entity component system. So go check that out if you want to learn a little bit more about that. And I've also done videos on the change filter as well as the shared component filter. But there's actually one more with method that I want to talk about right now, and that is the with store entity query in field. So basically what this does is this gives us a reference to the entity query outside of our for each function. So you see what I'm doing at the top of the system. I'm just defining this new entity query called soldier query, and then you'll notice that I actually access this soldier query inside the onStart running function. Now we can do that because this entity query that's defined inside the for each, this is actually generated when the system is created. So that means that we can actually reference this soldier query, the actual query, before this onUpdate function even runs. So you see in the onStart running, we can basically just do a debug.log that gives us the count of how many soldiers that we have based off of this entity query right here. So come back to Unity, enter play mode, and then you'll see that in our console, we see that there are 130 soldiers in the parade. That about wraps it up for entity queries inside entities.forEach functions. However, there's still ways that we can use entity queries outside of entities.forEach functions, which is what we'll be going over next. So now I'm just going to go ahead and disable this system here so we're not getting any confusion with systems overlapping each other. And we'll move on to this other system that I've created that's a very similar thing, except this time it uses an iJob entity batch to process all the entities. And that's because we're actually going to be basically defining the entity query manually rather than having the entities.forEach function generated for us. So you see that it's pretty easy to set up these entity queries. We can just use the getEntityQuery method if we're inside of a system base class. If we're outside of a system base class, we actually have to do something a little bit different, which I'll talk about in a minute. But you'll see that we're just setting this variable soldier query equal to getEntityQuery, and then inside here, this is where we actually define the components that we want access to. So if we want, we can just do a type of translation. However, we need to be a little bit careful when we just use this regular type of, even though it's very easy to do it this way. This basically means that we'll have read and write access to this translation component. So if we want to actually do it where we have a read only, we can use this component type.read only, and then inside the type brackets, we can just pass in the soldier move data. Now they do also have a component type.read write where you can pass in the translation. I think either the read write or the type of is fine to use. It's probably best.
This has changed. How to use write groups the right way. How to use UI. Oh.
Hello and welcome, I'm your Code Monkey, and I've just published another update to my DOTS course. This is one of the most important ones. This time it's having 15 new lectures covering all about making a DOTS grid system and flow field pathfinding. This was a really tricky subject to make into understandable step-by-step lectures, but I managed to make it. The lectures start off very slowly, introducing all the concepts and all the limitations of a data-oriented design, and then bit by bit, we're going to implement the whole grid system and the pathfinding algorithm. The pathfinding itself is the flow field algorithm as opposed to A-star, which is an interesting thing. It has some pros and cons, with the main benefit being how flow field works really great when you have tons of units, just like in this game. We're going to build the pathfinding and make all the units follow it, then of course make it all super performant with a bunch of optimizations and heavy use of the job system, and in the end, the pathfinding runs in just 0.27 milliseconds. That is super impressive. That speed, especially considering how there's still room for some improvements, making it that fast really showcase the awesome power of dots, so this is really super impressive. And of course, remember how you don't have to make games 100% with dots or 100% with game objects. You can mix them both. So you can, for example, follow these lectures, learn how to implement flow field pathfinding in a super fast manner, and then implement this pathfinding system in your own game object-based games. So you can make like an action game 90% using game objects, and then just use a handful of entities and this flow field pathfinding to make it super fast. And with this update, the course is now packed with tons of knowledge. It's got almost 15 hours. For example, here's the 3 overview lectures. We're going to build it in a data-oriented manner. Okay, so let's see the grid system that we're going to build. Now, if you're a regular with my videos, then you've certainly already seen me use a grid system plenty of times. It's a super useful data structure with so many use cases in game dev. It is really just a way of splitting the entire world into various grid positions and then be able to store some data on each of those grid positions. However, normally I use C# objects to build my grid, whereas here on this DOTS course, naturally we want to learn how to make it work in a data-oriented manner. This requires us to be a bit clever with how we set things up, but it's actually not quite that difficult. So first we're going to create the grid system, meaning an actual I system. Then we're going to use over here the onCreate in order to create the grid. Then we're going to use onDestroy for all kinds of cleanup. And on the onUpdate, this is where we're going to run all kinds of pathfinding logic. For storing the data for the grid, for that we're going to use mainly 3 data structures. We're going to first define a grid system data. This one contains the general data for a grid, so we're going to have the width, the height, the size of each grid object. So all the info that defines what is the actual shape and size of the grid, which by the way on this actually just one quick note, over here we're going to be calling it width and height. And for the grid positions, we're going to use the X and the Y axes. However, in our game, the grid is flat, so when applied to the world, this grid will actually be the XZ axis. But due to how the mathematics library already works, due to how it already has things like the int2, which contains an X and a Y, because now we're going to name our grid logic with XY. Now technically we could define our own custom type and do all the logic with XZ, but I think it's really pretty simple. Just keep in mind that the Y on the grid position, that one represents the Z in the actual world. Okay, so we have our width and height. This is going to be our grid system data, which is a normal I component. Then for storing that this code inside of here is
It's not really what we're looking for. Install our algorithm. I think they cover A-star in here. Steering against complex vehicles in Assassin's Creed Syndicate. Fast Cars, Big City, the AI of Driver San Francisco. Choosing search space representation. We're just going to be using literally a finite state machine because I don't really have a reason to not use one. Actually, we should continue on this one. On enter and use on update to periodically choose tactical positions. Move to cover, fire on the enemy, and do slow and steady. I can show you what we've got. I'm doing okay. I finally got some of the more complex systems down. I actually kind of like the camera. I think that it does a fairly decent job. There's still tweaking that needs to be done, but there's this really cool system that we have for when you're reversing the truck, it will actually like jump flip. Yeah, it is the Cinemachine camera. I take it you can tell because of the lines. But the Cinemachine camera cannot follow a entity. So it can't follow a dots entity. So you have to build that yourself. So what I did is I set up a follow target, and then I set up a yeah. My collision box is off on my car though. But the important thing is that we can drive. That's all that really matters right now. It needs to be fixed, but whatever. I can drive, and that's what I care about. The vehicle's actually kind of fun. The jumping is a lot of fun. And the suspension's pretty good. The suspension needs to be stiffer though. It's kind of really fun. What I need to do is figure out I need to figure out a camera with the Cinemachine to invert or like go around so it's a reverse camera, and then the flip will be a little better. But all in all, I'm pretty happy with the Cinemachine camera just follow by default. It's like actually surprisingly good. It's delivering air and death. So with Dots, we had to. I don't know if you were here for that, but with Dots, we have to build all of our own systems effectively. So we needed our own. We needed our own vehicle system. So I did that, but I largely borrowed from Unity because they had a demo networked racing game, and the vehicle there was a good base, good starting base. Still required like a lot of like learning on Dots interactions to get it working. Then there was the input system. Getting the input system working was interesting. There wasn't really a super great tutorial on that. So, but there was I merged a couple tutorials together and managed to get that working. Then I used the base of I touched on it a little before. Yeah. And then, so I got that working. See what else. Oh yeah, the camera was a bit of a pain. But I was able to utilize the input system, the base of the input system that I put together as a way to communicate out from the entity. So neither the input system or the communication to update the game object that the camera is tracking are actually entity are first compatible. So they are the slowest ones, which kind of sucks, but also like it is what it is. Like there's no way around that. But now since AI does not exist, we need to do AI, and animations don't exist, so we need an animation system. The asset store. And yeah, so like because animations don't exist, I went and I found this. But because animations don't exist, ragdolls don't exist, because the reason animations don't exist is because by default, the mesh will not follow bones. So there's a couple different patterns that you can use. None of them are super easy. And they revolve around a substantial amount of extra coding. But it's not something that's like, it's not something that needs to be reinvented. So I'm willing to, for this one, because of how much extra work it's going to be, I'm willing to bite the bullet and just pick up an animation system. Because the animation system for Ragdoll is different than the animation system for playing like a walking sequence. And one is more performant than the other. No. ECS is dots, yeah. So there's no animations in dots. There's tricks to fake animation, to fake it. So what you can do here oops, that's not what I wanted. So you can do this crowd simulation. And then what you can do is you can punt it to the GPU. And the GPU will take care of the animation for you. And I talked to the developer of this, and it actually works quite well. And then this also supports doing ragdolls, right? Because ragdolls ragdolls are a bit different, right? So here you can kind of bake your animations and then punt it to the GPU, and the GPU will perform all the work. So it's much more serialized, parallelized, and faster. So really good for big scenes. But the system for doing ragdolls is a bit different, and it's CPU based, because it has to go through the physics engine, and the physics engine is CPU based. So with that, you end up in a kind of wonky situation where it's like part of it needs to be, we want part of it to be GPU based, because there's going to be a lot of AI doing effectively the same thing, right? So we do that, and then we punt we punt all of that to the GPU, and we do that in parallel, whatever. And then we have like a trigger box effectively around the player, or some form of this. I haven't looked into it super deeply of exactly how this is going to work, but effectively you've got this space around the truck, and when the AI enters into that space, they turn into a rag doll and they go flying. So that works. And they get taken out, right? So we can work with that, but it's $120. And then we need, I might use a star. I need to find a path, the right kind of path tracing system. And it might be a star, and it might be something else. Yeah. I think this is dots compatible too, isn't it? Oh, it has potential for dots and integrations. Yeah, but this one's not dots compatible yet. And this also isn't actually what we want. So the idea behind this one is that like they more adapt to the terrain. Right? So like you see this going uphill, and it's the hills pushing back on the knee and stuff like that. Yeah. Where we just want a walk. Like we just want to walk. We don't even care about IK. Because you're not going to be able to see whether or not their foot slightly clipping in or something like that, right? Like, as long as they're relatively close to the ground, that's all that really matters. They could be floating like this far off the ground and nobody's going to notice, because by the time you hit them, right, doesn't matter. We just need to stick them to the ground, and then they just walk. I might not even put physics on them. Right? Like we might just have like essentially a ray that goes out in front of them and they move up to that location. Actually, that might actually be the way we do it, is we just ray in front of them. Unity. Other games do it with a nav mesh usually. It depends on your engine, but both Unreal and Unity both use a nav mesh to set up positions that the NPC can move to, And then you can query the nav mesh for a point that's reachable from where you currently are. And it's all pre-computed, right? Unity dots are ray cast GPU or CPU bound. Yeah, because we don't want to be casting array for every single. If we're CPU bound, we don't want to cast array for every single object in the for every single walking NPC, because that'd be too much.
On screen. Now it's worth noting that, when I'm using the job system, so let's see what that gets us. All right. So previously we got to around 25,000 game objects on screen. It puts us at 30 frames a second. And so now I'm going to run this. This is my component system. I'm going to start at 26,000. And I can see I'm already doing pretty well, around 100 frames a second. So let's just add some more. Let's see where we end up. All right. So I'm at 76,000, 86,000. Let's get to say 96,000. That's going to put us around 30 frames a second once they're all on screen. So 96,000 as opposed to our previous 26,000. You'll notice we're not doing any game objects. Now, I can see these in the scene. They're all there. They're all 3D ships. There's just a lot of them, right? 96,000 of them all moving around here. But there we go. So 96,000 ships on screen. Maybe we can go a little bit higher to get us to 30 frames a second, but you can see massive performance boost using the entity component system. And yes, it is a conceptual shift of saying, okay, I can't just have these individual objects with these individual scripts on them. I'm going to process these all together and I'm work with this sort of entity data. But there are just huge trade-offs. You get huge amounts of performance for doing that, and that's not even all. So this is 96,000. That's pretty good. However, I'm not currently using the burst compiler. I mentioned the burst compiler previously about how the burst compiler can add this all this new basically this vectorization stuff utilizing CPU benefits, things like that. Let's look at that. So I'm going to go to my jobs menu here, and I'm just going to turn on my burst compiler, my burst jobs here. Okay, that's all I'm doing. The great thing about the burst compiler is if I've implemented the entity component system, I don't have to do anything else, right? The burst compiler just works. I just get benefit. There's no reason not to. And so I'm going to go to jobs, use burst jobs. I'm going to hit play. Same code that we just looked at, and let's see where we end up now. So previously I went to 96,000 to get to 30 frames a second. So what does 96,000 put us right now? So 96,000 puts us about 50 frames a second. Let's keep going. Let's see how high we can get. And so I'm going to get to, I think I can do one more, 156,000. All right, so we started originally in the classic way of doing things, 17,000, which was really good. 17,000 game objects, granted they're not that complex. And using the entity component system with burst compiler, I have 156,000 objects on screen. Now it's worth noting that, when I'm using the job system, when I'm using the classic system, I'm basically CPU bound, right? Because it's all, either single threaded for classical or multi-threaded, but I basically just, I cap my CPU, and that's why I can't go any higher. But now with the entity component system with burst here, I am completely GPU bound. So if I pull this over here, you're gonna see that I'm using.
Okay, so we can go GPU bound if we use burst. So burst is GPU bound. Physics, Unity ECS, physics, raycast, burst. I don't think we can raycast inside of burst. collision detection. We're going to take a look at the raycast. There's a number of these, and we want to take a look. I'll find collider geometry during runtime. I think we'll need this. I'll want to take a look at it though. Add a new modify the results of contact generation to proceed. Filter out collisions by change. No, let's change scale. Modify collider geometry. It might be motion properties. Yeah, it's not that one. Huh. Where are you? Oh yeah, you know what? I guess this is like just in the project, right? Ugh. So let's see if these are burst compatible. Query closest distance. Query testing system. It's on destroy, on update. Ooh, this is a base system. God damn it. It's an I system. First compile. I wonder if we can build like let's see what happens when we have like 1,000 of these. Right? Let's duplicate this. Yeah, it makes everything a lot faster. Thank you for the gifted sub, Anonymous. Anonymous, you've been great. You're helping support this so much. I really appreciate it. Whoever Anonymous is, you are amazing. You're gonna help me pay rent. What? What? Interesting. Oh, I'm just trying to make sure that I can, like, how many of these can raycast with each other before we run out of performance? This is the real question, right? How much performance are we sacrificing by doing this? Maybe, maybe not though. Like, maybe this won't be a problem. You know what? I think we're probably fine. This is how we're going to do it. 40K tries, nothing? Yeah. First compiling will do that to you. The problem is that I don't really have a way to make it that big. But the idea is there, right? Yeah. So this is the physics material thing, whatever, that we need to probably do to all of these. So we'll probably be fine. How am I doing today? I'm doing pretty good. We made good progress on the game today. We It's more like a kick flip. Because he's not actually flipping. Like, upside down or anything. It's just flipping around. Or maybe it's a shove it. I don't know what the it feels like a skateboard. It feels like something that you would use like it feels almost like Tony Hawk Pro Skater, right? This actually does feel like this actually does feel like you're a little bit like Tony Hawk Pro Skater. Yeah, something like that. But we got the wheels also working, right? So they go up and down. That you can't see, unfortunately, because of the camera, but the idea is there. You can kind of see it. They also do rotate. They don't just glide. But we're not worried as much about that, so. And then we get down nice and low and we do our flip. There we go. Right now the collision detection's a bit off for like the front of the truck. So, but yeah, we're all there. It's beautiful. What more does the truck need? Proper handling, better suspension because look how deep the truck goes down. Proper collisions, textures, gears because there's no gears or RPMs. It has one speed. Proper braking because right now we have reverse, but that's it. We don't have an e-brake. Air control, maybe. Maybe we need air control, hey? But it's fun nonetheless at the moment. Yeah, no, it's really coming along. The performance is really good too. I think this is going to run on more computers than if I stuck with Unreal. There's a game I'm going to be starting with Gaz soon too, and that one's going to be. I don't know if I want to do that in Unreal or Unity. I'm kind of leaning towards Unreal because I can pump out a game in Unreal a little bit faster. Just because I know Unreal better, right? And the one with Gaz is going to be kind of like a it's going to be kind of a what is it? Game jam game, effectively, but more polish. The idea behind that game is that we get it out quickly and get a Patreon up and stuff. No, this waifu, this truck brings the waifu. Ah, the camera's mostly done. This is the bringer of waifu. It either brings the waifu to you or it brings you to the waifu. One of the two. It really depends. Or maybe it brings you to the husbando. It could be either or. It brings you to the harem. Indiscriminate, doesn't care about gender. Yeah, probably. I don't know all the details about how I want the camera yet because we don't have a big enough world to deal with it. Yeah, no, I'll probably adjust that so we don't get a lot of, because like, yeah, there is some tilt right now, but it's not a ton of tilt. I wonder if it would be a problem. Yeah, as long as you can toggle it. What? I thought I just banned this person. Yeah, it's pretty ridiculous. Yeah. The reason why I'm saying like the tilt is like once I actually have the vehicle driving the way that I want it to, I don't entirely know what the transitions between the different like rotations are going to be. I have a feeling that like I don't want the rotate like the tilt anyways because I feel like right now it feels like you're on a skateboard. And that's not what I'm going for. Like yeah, it doesn't feel like you're driving a vehicle. But it gets the job done for now. And that's what's important. But yeah, no, I think the tilt is going to go. I imagine the tilt is easy to fix too with Cinemachine. I feel like it's just a checkbox. Yeah, like that might be the case, but I don't know, it's hard. It's hard to tell what the right thing to do would be. But all I'd effectively have to do is just remove the tilt from the follow target and then it would be gone. Yeah. I don't like ruling things out when we're this early in development. Just because I don't jump to it doesn't like just because I'm not set on it like right this moment doesn't mean that it won't happen. But yeah. The truck tilt is kind of fun though. Yeah, it is a little fun, but like it also doesn't quite feel right. I feel like there's a tiny bit of tilt in the camera on Unreal, and the Unreal camera I kind of like for the most part, except for like it doesn't have the easing in and easing out kind of thing. I also need a backup cam. So I'm kind of curious about how backup cam would work. Because like in Unreal, what you do is you just have two cameras. One points backwards and one points forward. And then you just adjust the cameras effectively the same way. But because they're not being displayed, they don't. Well, because it doesn't get displayed, right? It means that like it doesn't, yeah. No, I actually want it to like turn around. Like when you do a reverse in a regular driving game, right? Like you actually look behind your car. And I think that's actually important. Oh, okay. Yeah. Then that's kind of what I was thinking. Will that like disable rendering on that camera when it's not being viewed? Oh, okay. Sweet. Then that's exactly what I want. Effectively just like a front facing one and then whatever. And then like yeah, because like another one that was suggested and we tried it out and it was horrible was a first person cam. Like from the driver's seat. Yeah, that was horrible. It felt bad. What game input does this game go for? I test it with controller, but I also have keyboard bindings. No mouse at the moment. I don't know if we'll have mouse at all. But definitely a keyboard. There's keyboard and there's controller. Although we prefer controller. The reason you want controller is because controller has more than on off. Yeah. It's also what I like about the new input system in Unreal that came with 5.0. Took a little bit to get used to, but it works almost identical to the Unity one. Yeah. I'm so for the game that I'm going to be making with Gaz, that's going to be kind of like a it's supposed to be, we're going to try and put together pretty quickly. I think that game right now, I'm thinking that it's going to be almost akin to a Pokemon battle system, right? Where it like goes back and forth like that. And yes, just hear me out. It's going to be Pokemon battle system like that kind of turn taking kind of system, and where you use moves, and you know, the first to no health, or the first to maximum whatever loses, kind of thing. And I can't decide if I want to do this in Unreal or Unity, because I haven't done anything with Unity UI yet. So I don't know how good or bad the Unity UI system is compared to UMG. I think it's UMG. So I could go like the Unreal system, and that would totally work for me. But like, I also don't know, because like if I go Unreal, I need to use their advanced UI system. What was it? I can't remember the name of it, but like they have a secondary UI system. No, I imagine it's entirely different. Because I think for the most part, the entire game could be effectively like, you have a 3D background, and then most of the combat part of it is all done in 2D, right? And it's just like buttons. You just press buttons. And we'll need to have like controller support, so like you'll have like up, down, left, right on your controller, A, B, to interact with that. And then you could also use your mouse to just press the buttons, and then you also want a keyboard to be able to navigate through that. For Unity, there's 2 systems. Okay. Yeah, because I'm going to need that for this game as well, right? Because I'm going to have a menu system, right? But I know how, common UI, that's what it is with Unreal. Like I'd have to use common UI in Unreal to make the system. I'm using common UI in this the Unreal version of this to effectively get the same thing. UI toolkit. It's like let's take a quick look into this. Unity UI toolkit. You said this is the new one, right? Links properties to the controls that modify their values. Layout engine. Layout system based on the CSS Flexbox mode. Interesting. I'm kind of leaning towards I'm kind of leaning towards Unity for this, just because I want to try and make it as performant as possible. And UE is going to have a higher baseline performance, and we're never going to hit I don't think that we're going to hit the even out point with between UE and Unreal. Like I think we'll always be under it in Unity. So it's I'm not sure if it's like the best of ideas to even bother with Unreal for this. The only reason to even think about Unreal for this is that like Unreal is what I know better, so I could probably pump it out faster, but like Unity is not particularly difficult, and neither is C#, so. Excuse me. I'm guessing it's something like
UI
this.
Toolkit is Unity's new UI solution. It is virtually better than the default UI system in just about every way. I especially love how it has easing built right in, and I will show you how to do that. But this workflow is a little bit more complicated, and it's harder to get your head around at first. So my goal with this video is to give you a brief and easy introduction to UI Toolkit by building a simple main menu. Ready? Let's go. So I have an empty scene here. To get started, let's right-click on our hierarchy and select UI Toolkit, and click UI Document. And I'm just going to name this main menu. So this created a game object with a UI document component, and it also created a UI Toolkit folder in our project. It has some panel settings and a theme style sheet. Don't delete.
Wait, what did I just miss?
To get started, let's right-click on our hierarchy and select UI Toolkit, and click UI Document. And I'm just going to name this main menu. So this created a game object with a UI document component, and it also created a UI Toolkit folder in our project. It has some panel settings and a theme style sheet. Don't delete the theme style sheet or your UI will not show up on the screen. Now our UI document is looking for a visual tree asset, so let's create one. In our UI Toolkit folder, let's create UI Toolkit, UI document. This is going to generate a .uxml file or a visual tree asset. I'm going to call it main menu visual tree. And let's plug that into our UI document component.
Oh god.
Now before we open this up, let's go to our panel settings for a sec. I'd like our main menu to scale with screen size so that no matter what resolution, it scales with that. And I'm going to set this to 1920 by 1080 as well. So to actually build our main menu, we need to go to the UI builder, and we can double click this to open that up. So if you look, this really isn't too far off from the Unity window, actually. We have an inspector over here, our viewport here, a hierarchy here, as well as a library of containers, controls, and numeric fields that we can drag in if we want. First, I'm going to select our visual tree asset here, and I'm going to change the canvas size to the resolution for our game.
So I guess the big question that I have is, can we make the background transparent so I can have things going on in the background? It's very important. I need to have a 3D scene animated in the background while this UI is over top of it. Asking for a friend.
And you can hit fit to canvas to get this to nicely. So first, I'm just going to get a heading to show up. To keep things nice and organized, I'm going to drag in a visual element. You can think of this as a container. In fact, let's go ahead and name it container over here. Now inside this container, I'm going to add in a label. Now before we go any further, this is the perfect place to introduce style sheets and use them to our advantage.
I guess container would be like the canvas in Unreal. Like you want to limit those.
Up here, if we click plus, we can create a new USS, which stands for Unity Style Sheet. These are files that are very similar to CSS files if you've ever done any web development. Do not let that scare you off though, because we can do everything here in the UI builder if we want. We don't have to manually type it out, but we can do it that way if you want. I'm going to create a new USS and call it main menu style. Now within that style sheet, we can create what are called selectors and apply those selectors to as many elements in our hierarchy as we want. So let's create one.
It's kind of cool.
Now let's apply that selector to our label. You can drag and drop it on, and if you don't want to do that, you can go over here and search it and press enter. You'll know when it's applied when it's highlighted like it is here.
This is nice. The CSS style stuff.
Now to show you how useful style sheets are, I'll temporarily create a new header. First, let's call this one header, and call this header 2, and make sure we apply the .header style sheet to it as well. Another nice visual way you can tell the style sheet has been applied is if we highlight over the selector, you'll see it highlights both of the labels, which is great. I'm going to select our header selector and make its font size 40, and make it white. So already, hopefully that makes it clear. Any changes we make to the style sheet changes all the items that have that style sheet applied to them. Now, of course, you can overwrite the style sheet and change individual properties. I'll make this second one black. Now, kind of like prefab game objects, it bolds the property overwrite. So now if I change the color on my style sheet, it's only going to affect the first one because I'm overwriting it in the individual property here. You can undo the overwrite by right-clicking, and it gives us the option to unset just that one property or all of them. You can hit Control plus S to save.
Yeah, I might just give it a try out with Unity.
You'll notice that we cannot see this in our scene view, which is probably my favorite thing. No more UI covering up your game objects in the scene view, but if you go to the game view, our text is right there, whether we hit play or not, as long as this script is active. As soon as it's not, that text disappears. All right, so next let's set up a couple of buttons. Go ahead and delete the second.
Oh, I like that. I like that a lot.
And also let's change this to say main menu. And now I'm going to drag a button on there. Now let's create a .button selector in our style sheet and apply that to our button. I'm going to change the text size to 20 and change the width. You'll notice that auto just fills out the whole visual.
Can I make prefabs for like the buttons and stuff like that?
Element container that we set up. So I'm going to change this to 220 pixels and 60 pixels tall. Let's center the alignment. If we go to border, we can actually round the corners. I'm going to bring up the radius to 10 pixels. And if we go to background, we can change the color if we want. But actually, I'd rather use a button sprite. I got this pack from Unity's Dragon Crashers demo, which is linked in the description. So we can choose from a texture, a render texture, a sprite, or a vector, which is awesome. I'm just going to bring in a button sprite. I'm going to increase the margin at the top a little bit. And I'm going to make this one say start. Okay, now let's make another button and assign our button style sheet to it. And make this one say settings. So let's do what we would do if this were a real game and make it not super ugly. I'll start by assigning a background. Again, I grabbed these from Unity's project, which is free. This is a nice 1920 by 1080 sprite. So in our visual element container here, let's assign a background to it.
We dismissed the ads.
I also brought this font here from the same project.
The ads.
So I'm going to assign that font to our header style sheet and delete out the font asset. And I'm actually going to bring that up to like 100 and center it. And same with the button style sheets as well. I'm going to change the font and make them white.
No ads. Next
There we go,
ad
much
in
better.
5 minutes.
So next, let's look at how to assign on-click events to these buttons so that something actually happens in our game when we click on them. In our project, I'm going to create a new script called main menu events and attach it to our main menu game object and open it up. So first, to get UI Toolkit elements, we need to add the Unity Engine.UI elements namespace. And I'm going to get a reference to two things, our UI document and our button. By the way, if you're enjoying the video, then thank you if you leave a like or a comment. So in a wake, I'm going to get a reference to our UI document. It's sitting as a component on this game object, so we can just do a get component call. And as for the button, the syntax is a little bit strange, but it's not too bad. We're going to reference our UI document and find the root visual element, meaning where the hierarchy starts in our UI document, then use .q, which is short for query, and we'll find the name of our button, which I actually forgot to do. So I'm going to go back and call this one start game button, and this one settings. Now back in our script, I'll search for the string start game button, and this is going to return a visual element, but we can cast it as a button. Now we register a callback to the button. So we'll say button.register callback, and there's all sorts of event types you can choose from. I'm going to choose a click event, and we'll call a method called onPlayGameClick, and we'll set that up down here. We're just going to need a click event passed in as a parameter, and we'll just throw a debug.log when we press it. I'm also going to unregister the event if we disable the game object, as that is good practice. Now you can see if we click play and I click this button, we get our log message. Now, if you have an event system in your project, the click event type we just registered to is actually tied to this left click here. You can see I added enter on my keyboard here. Now you can see if that is the selected button and I press enter, that works as well. Hopefully that is enough info to get you started if you want to make a menu that works with keyboard and gamepad as well. Now we might have a whole bunch of buttons, so it might be a good thing to know how to subscribe a whole bunch of buttons from a list instead of one at a time like we just did. Let's say, for example, practice. Now you can see if we click play and I click this button, we get our log message. Now, if you have an event system in your project, the click event type we just registered to is actually tied to this left click here. You can see I added enter on my keyboard here. Now you can see if that is the selected button and I press enter, that works as well. Hopefully that is enough info to get you started if you want to make a menu that works with keyboard and gamepad as well.
I think
now
so.
we might have a whole bunch of buttons, so it might be a good thing to know how to subscribe a whole bunch of buttons from a list instead of one at a time like we just did. Let's say, for example, we want to play a sound whenever we click a button. So to do that, I would set up a list of buttons. And instead of q and passing in a string, I'm going to use query and the type button and use .toList. Now I'll just do a for loop and register a callback for each button in the list. And we'll call a method called onAllButtonClick. And again, we'll unregister those in onDisable as well. And what the heck, let's actually make it play a sound. So we'll grab an audio source, and we'll play it in our event here. I'll just quickly add an audio source here and assign this sound, and make sure play on awake is off. There you go. Okay, now I want to show you the built-in transition animations, which are easily my favorite part of this new system. You'll notice that on any of our elements, we have this transition animations right at the bottom here, but it's not quite as simple as just playing around with those values, because we need to tell it what it's transitioning from and what are we transitioning to. So essentially, we need a start and an end, and we control the start and end through different selectors here. So let's animate our buttons when we hover our mouse over them. Now the cool thing is our start is already done because we already made a .button selector. So to set up our end transition, let's create a new selector and call it .button::hover. Now the naming here is really important. You cannot just call this whatever you want. The hover that we assigned with a colon is called a pseudoclass, and in the case of the hover pseudoclass, it will call an event whenever we're hovering our mouse over a visual element.
This is really
I will link down below to all of the built-in pseudoclasses for the UI toolkit. Now the fact that we've added this pseudoclass to our .button selector means that it will apply to all of our visual elements that have the .button selector applied to it. If I wanted, I could do the same thing for all labels, for example, and say label hover. What that would mean is the hover event would fire whenever I was hovering the mouse over any label in our menu. So pseudoclasses and the naming convention is just something important to keep in mind. Now we said this .button hover was our end transition, so let's change what we want to actually change it to. I'm going to scale the buttons up to 1.1 on the X and the Y, and maybe tint them red as well. And finally, in order to actually trigger the animation, go back to our start element and change the duration to something above 0. If you want to test it in the UI builder, you can hit the preview button here, and if we highlight over our buttons, you can see they transition very nicely. You can add delays in there as well, and instead of transitioning all the changes we made all at once, we could do each one separately and stack them. It's very easy to do. And we have all these different easing options here, and I will leave a link for this easing graphic as well, but these are all of your standard easing options, and they will let you animate with some style very, very easily. If you are looking for more info on UI Toolkit, I will have a bunch of links down below, including Unity's UI Toolkit sample projects. There's actually 2 of them, but I recommend QuizU to learn more about UI Toolkit because it's smaller and it's a lot easier to digest. There's also a whole UI Toolkit ebook, which is loaded with information. This system is still undergoing a lot of changes. Personally, I would use UI Toolkit for menu building in a commercial game now, but I would, for now, avoid it for your world space UI needs, as it's currently a whole lot easier to do that with the old system. But for menus, this is far superior to the old system. That's all I got. Bye.
Did you make a second one?
UI Toolkit is now the recommended way to create editor scripts for things like custom inspectors in Unity. As of Unity version 2022.2, I believe, Unity actually switched from IamGUI, and now all their default inspectors are drawn using UI Toolkit, which you can see is being confirmed with our UI debugger here. This video is for you if you don't know much or anything about editor scripting, and you want to get your feet wet and learn.
Okay. Yeah. All right, we're at 7.5 hours. Well, almost 7 hours and 40 minutes. So I am going to call it there. Just going to snooze this ad so we're not leaving on an ad. We're going to go raid Rem because he's going to be the artist for the game that I've been building during stream. Well, the character artist. So anyways, I'm going to take off. I've got some dishes to do, and then I need to do some housework essentially. But I will be back tomorrow for another around 7 to 8 hour stream, starting nice and early in the morning. So I will see you later. Ta-ta for now.